Okay, can, yes. So you get a k plus 1, you flip it around. Then after that, you realize, oh, there's a 3 over 2 in front of it. So you just multiply by 3 over 2 here and there. But do you need to change the direction of the arrow? Don't need. Why? Because 3 over 2 is positive. Okay? Then this is just y over x. Then you just sub in, and then you get your answer. Equal and not equal. No, they are just rewriting it in a different direction. Oh, they read it from left to right to left. Then in terms of interval notation, it will be 3 over 4. Got equal sign, so it's square bracket. 3 over 2, no equal sign, so it's round bracket. Y over x is an element of this interval. Like this. It's set notation. This guy. Is that okay?
Okay.
Can, good. Now part 4, what did they ask? Part 4, find the value of k for which the box has square ends. So square ends just means what? It just means that instead of box looking like this, where it's a rectangle, you make it into a square. So what can you tell about the y and the x? They must become what?
Like the same.
The same. X must be equal to y. X equal to y. Then you just need to redo the entire question. But this time, think of it as x equals to y. Let's see. How did they do it? When the ends are square, the y is equal to x, right? But wait, that means that y over x is equal to 1, right?
Oh,
you can divide by x because x is not 0. X is a length. Maybe I should say x is not equal to 0 since x is length. Okay, it's more than 0. X is more than 0. So it's safe to divide by x. But yeah, anyways, what's y over x? Y over x is what we found just now over over here, right? Then you can just sub in, and then you solve for k. Is that clear?
Yeah.
This one sub in as y over x equals to 1. Then just continue and solve for k. All right, good. Ken. Then that's question. That is question 12 done. Any questions?
No.
No. Okay, good. Then let's just move on to 14. No, 14 done already. Question 20. Question 20. Let's look at the question. So you have an isosceles triangle that has a fixed base of length b. The other two sides of the triangle are each decreasing at a constant rate of 3 cm per second. So we should draw in the two other sides. And since it is isosceles triangle, those two sides must have the same length. So we denote them with a letter x because we don't know their length. Okay. Then they are each decreasing at a constant rate of 3 cm per second. So straight away, when you see rate, you have to think it's d something over d something. Okay. So in this case, it is x with respect to time. They didn't say with respect to time, it's implied to be with respect to time. And also they gave the units here, so it's obvious. Per second means time. So 3 cm per second. Or you could even write it as 3 cm, then s power -1. Yeah, then, okay, that's dx by dt, that's fine. Moving on, how fast is the area changing when the triangle is equilateral? So equilateral means what?
No, like all the sides the same.
Are all equal. So that just means that the x and the b are all equal. Okay, so that's a special case. Here we consider this to be fixed, right? Then those x's are variable. Okay, fixed or constant. So that means that if we want to find how fast is the area changing, we're actually asking us to find dA by dt, right?
Yeah.
Right, rate of change of area with respect to time. Then you know the trick I went through with you. Just have to split it up like that. dA top left, dt. Oh, Ivan. dA at the top left. Sorry. dA at the top left and dt at the bottom right. Then you introduce something that's the same on both sides. Since they already gave us dx by dt, what's the missing letter that hasn't been used yet? Must be dx. So you just fill in the blank with dx. See, it's the same question every time. Just take this, split it up, top left, bottom right. Then you introduce a letter that was already given. Okay, sometimes you may need to split the chain. This is called chain rule, but you may have to split it into 3 separate fractions. So you might need to have a fraction, have something in between. Hey, what did I press on? I'm not sure what's going on. Okay, never mind. Yeah, you might have to introduce something over something, and then you times a dx like that. Okay, or maybe the dx could be over in the center. The dx could be at the center, and then you need to introduce something else so that they cancel off. They cancel away. Like a dy. Some of the more difficult questions. Does this make sense? X and X cancel, Y and Y cancel.
Yeah.
Yeah. So you can imagine it keeps on going, right? The chain. But usually they won't ask so difficult questions. Such difficult questions. The chain rule. But you don't need such a difficult version. Just the normal fraction will do. Okay, hold on a second. Yeah, so anyways, you just need a dx by dt and a dA by dx. Okay, so how do we find dA by dx? So that's when you need to realize that, oh, wait a minute, we have a formula for area of triangle, right? Half times base times height.
Yeah.
Then we can use that. So in this case, what would it be? They gave us the expression already, half times base times square root x square minus b over 2 bracket square. Where do you get this from? How do you find the height? Got square root and got square and square.
Or can use Pythagoras theorem.
That's correct. So you just have to drop a perpendicular, realize that there's a right angle triangle here, or the left side or right side, doesn't matter. This will be equal, right? This will be a midpoint. So that just means the length over here must be how much? B
divided by 2.
Divided by 2. So now you can just b over 2 bracket square plus h square equal to x square. Then you solve for h, you get this. The height. Is that okay?
Yeah.
Can good. Then then that's the area in terms of a variable x and constant b. Then how do you find dA by dx now? Just differentiate. Is that clear?
Yeah.
Square root is the same as power half. Okay. You know this. Then I don't need to go through in detail.
Yeah. Okay.
Okay. Half bring down, then minus 1. That's why you got negative half. And then chain rule. Okay. So you got dA by dx. What do you do next? Do you immediately sub in they said, equilateral, right? The specific case where it becomes an equilateral triangle means all 3 sides equal, which also means that x equal to x equal to b. So x equal to b, do you substitute x equal to b straight away?
No.
Or do you do the substitution at the last step?
The last step.
Write this down. Right? Very important. If you sub in if you sub in early, you're gonna get confused. You cannot solve the question. Substitution of x equal to b is our last step. Okay, so this question is difficult because they use length b instead of just giving you an actual length like 3 cm. You can just pretend that the b is just some number, 4 cm, whatever number it is, just a fixed number. Then you must always remember substitution must occur at the last step. After all the dust has settled, you found your dA by dt expression, then you sub in. Okay, so usually, not usually, it's always. Okay, then so you just sub in over here for dA by dx and then dx by dt. But we already know dx by dt is 3. Actually, let me think a bit. Oh wait, it's decreasing. It's decreasing. So I'm wrong here. It's not positive 3. It should actually be negative 3. Okay, then dx by dt here, you sub in with negative 3. What else? Then now they also sub in x equal to b. Only at this stage, then they sub in the x equal to b. Okay. Or actually, at this stage, after you find dA by dx, you sub in x equal to b, is still okay. But if you sub in x equal to b at the area stage before differentiation, then that will be a problem. You remember the inverted cone Amax question I went through with you, the water dripping out?
Yeah.
So it's the same idea. It's the same idea. You don't sub in the value at the area. If not, you'll get a constant. Then with area being a constant, you can't really differentiate it. If you differentiate, you get a 0. That's not very useful. Okay. Okay, then dx by dt is found. Sorry, dA by dt is found. You just need to simplify. And you realize that you get this as your answer. Just be careful of the units, cm squared per second, and there is a negative sign. Okay?
Okay.
Good, good. 20 done. Let's move on to 21. So, okay, I didn't check your work, Okay, 21 is blank. Okay, so 21, let's read the question. The given diagram shows a vertical pole AB of length 2 meters on a horizontal ground, with points A and B representing the top and bottom ends respectively. Moving point P approaches the pole on a horizontal path 3 meters above the ground. So traveling like this at a constant speed of 2 meters per second. If the theta is the angle APB, so this angle, and once it moves to a different position, that angle, once it's this position, that angle. Can see? Angle, angle, angle. Can? Okay. So if theta is the angle APB, all these different P's, find the rate of change of theta with respect to the time when P is at a horizontal distance 8 meters from the pole. Okay, so can you understand what this diagram is doing? What is X?
The ground.
No, more specific. Last 2 lines. X is the
horizontal distance.
From the pole. Okay. Then we let it be a variable. Let it be a variable. And then you want to figure out some dx by dt and d theta by dx and some other derivatives. And then finally, we're gonna sub in the last value, x equals to 8 as a last step. So can you underline this for me and say sub x equals to 8 and then bracket last step?
Okay.
Okay. So now we have to consider all the variables here. Using the diagram, actually, let's just write down some of the things that they mentioned. I haven't convert into math. Here they told us that constant speed of 2 meters per second. It actually means what? Dx by dt is equals to
0.
No. Distance against time, also known as speed. Rate of change of the distance, horizontal distance against time is also known as speed, which is 2. However, what is happening in this diagram? What is happening to your x? Does it as time increase? Increase or decrease?
Increasing.
The x is increasing? You imagine, this is the x. Okay, when P is at this one. Okay, I'll label it P1, P2, then P3. P1 is moving to P2, and then P2 is moving to P3. At first, it was this shape. There's a horizontal distance. Next, you move to this shape. There's a horizontal distance. Did the horizontal distance increase or decrease? And then you finally move here. Horizontal distance here. So it goes from this to this and then to this. So it's decreasing. What do you know about decreasing? Must be plus or minus?
Minus.
Must be a minus, right? Because x is decreasing. So -2 units or meter per second. Okay, dx by dt found. Next, theta is a angle APB, rate of change of theta with respect to time. See this one, they are detailed. They told you with respect to time. So that means that you want to find what? D theta by dt. Okay. Hey, you see this guy? You see that guy that's given? This is given, sorry. What should we do? What should we do? Should we work with the given and split, or should we work with the one and we split?
The given.
What with the given? Yeah, not a good idea. What with the want? Then you do the splitting. You remember the trick? Splitting? Maybe I try to swap the positions around so I have more space. What's this? Hey, how come got two lines?
Oh, so must do with the one you want first.
Yes, I recommend it. So here's how I would do it. I'll start with what I want. Always start with the objective, and then you split it up into two fractions. So I see the top guy and the bottom guy. It goes to the top left and the bottom right. Standard trick. Then you introduce a d something that is the same at the remaining spaces. What do you think is the d something?
The x.
Yes. Why? Because it was given over here. And what's so nice about this second fraction?
Is given.
It's just a -2, so we can immediately sub in with -2. But then d theta by dx. Now we got a problem, right? So what is d theta by dx? That means we need a theta is a function in terms of x. Then later we can find d theta by dx. Okay, so that's the natural thought process, right?
Yeah.
So now our working backwards, it means that we need to find out theta in terms of x. Make sense?
Yeah.
Start with what you want, and I'm slowly working backwards. So that's why the question started off like this. Theta equals to angle APD minus angle BPC. Can you see that? This guy minus away that guy.
Yeah.
Big angle minus small angle. Okay, good. And then what is the big angle APD? It's tangent inverse of x. Why is that the case? Big angle APD is actually here. So it's part of this right angle triangle. Can you see? And APD is this pink color angle. So maybe if I just redraw the triangle. Opposite is x, right? And the adjacent? Total height 3. Here is 2. So what's the remaining length?
5. 1.
1. Yes, so it's 1. Then from there you can tell already, right? Tangent of the angle APD is actually equal to opposite over adjacent. Is that clear? This one?
But how I know the opposite?
Opposite over adjacent? It's x. Now this length AD and CB is a rectangle. That's why it's equal.
Oh, okay.
Right? Is that the part you're confused by? Why it's also x?
Yeah.
I mean, this is also equal to x. Okay. Clear now?
Yeah.
Okay, good. Then after that, you can just make angle APD a subject by taking tangent inverse. Okay, that's how they get tangent inverse x here. Can? Okay, then how about BPC? It's the same thing. So angle BPC, it's another hidden right angle triangle over here. Right? Let's just label it as a blue angle over here. So maybe if you want, you can redraw the triangle. I think it's easier if you're confused. B, then P, then C. There's the angle BPC that I've labeled in blue here. We got a X here and we have a 3 here. Is that clear? How I got an X and 3?
Yeah.
From the diagram. So tangent inverse of X over 3. Why? Because tangent of angle BPC must be opposite over adjacent. In this right angle triangle above, it is X over 3. Then to find angle BPC, just bring the tangent over. Tangent inverse X over 3. Okay?
Yeah.
So you got an expression in terms of X. Then you just differentiate. Just use the formula list. They provided the formula for the derivative of tangent inverse. 1 over 1 plus x squared. But here, a bit special, when it's x over 3, you have to sub in with x over 3. And then you need to do chain rule. Okay?
Yeah.
because x over 3 is not just x. Then after that, simplify, you get this expression. Then so on and so forth. Just after you find your theta by d theta by dx, can you immediately sub in x equal to 8?
Cannot.
Actually, at this stage, you can. It is d theta by dx. Actually, you can, but try not to. Do it at the last step. How about at the theta stage, when theta equals to tangent inverse x minus tangent inverse x over 3? Can you sub in x equal to 8?
Cannot.
Cannot. That one really cannot. If you sub in at this stage, what happens? Tangent inverse x minus tangent inverse x over 3 becomes tangent inverse 8 minus tangent inverse 8 over 3, which is just a
Constant.
theta equal to constant. Can you differentiate?
Cannot.
I mean, you can, but then it will become 0, which is not useful. Okay, we don't do that. Can I substitute instead at the last step here? Specifically, you write down d theta by dt, which is your objective. You split it up into the two fractions. Dx cancel away. But of course, you don't get cancel away and go back to d theta by dx. Please don't do. If not, you're just taking one step forward and taking one step back. Here we are introducing a dx purposely so that we can replace dx by dt over on the right side with a negative 2. Okay, they did it on the left side to make it look nice. And then the d theta by dx, we just replace with whatever we found above. And then you get this expression. Here they use radians inverse. I think it's a bit extra already. I don't need to care about the units here. Oh, sorry. No, that's not what they meant. They meant radians and second inverse. So, sorry, not degrees. This one is radians. This one is inverse of a second. Inverse of 1 second. Or you could just put down radians per second. Why radians? Why not degrees? Because differentiation integration. Differentiation integration topic, also known as calculus. All of our rules involving the derivative of sine, cosine, tangent, sine inverse, cosine inverse, tangent inverse, especially this part here, it all assumes that x is radians. It requires that the x is in radians. Okay? The proof, like, have you ever wondered to yourself, why is the derivative of sine x equals to cosine x? Don't care lah, just memorize.
Yeah.
That's the intention of H2 math, but just memorize, unfortunately. But the reason, if you want to find out, you have to study math in university, or you can Google on yourself on your own. But basically, in that proof of why the derivative of all those trigo functions, in particular, one example being sine x differentiate and you get cosine x, it requires the assumption that x is in radians. If it's in degrees, you have to convert into radians first, then after that you differentiate. So you need to use chain rule. In other words, if let's say, for example, you got, I don't know, the y equals to sine theta, where theta is in degrees. Theta is in degrees. Then how do we differentiate dy by d theta? We cannot differentiate unless we do one more step. We have to convert this into radians. So pi over 180 degrees times theta. Okay, this one should be theta degrees. Okay, degrees. Then the degree will cancel away. You're left with pi over 180 times theta. Then that's when you can differentiate dy by d theta. You can convert this into cosine, and then copy and paste the insides. And then chain rule tells you need to times pi over 180. That's your answer. Did you know this?
No.
The angle must be in radians. Need to memorize one.
Yeah.
Yes, and the sine becomes cosine. This rule only works when the angle is in terms of radians, not degrees. Okay, moving on. So anyways, that's why this is radians. And are we done? No, we need to now sub in the x with 8. So remember the fancy notation I tell you? Draw a vertical line, x equal to 8. You can forget the units, never mind, not so important. You never write, I don't think they will penalize you. Just write x equal to 8 here. And then you sub in, then you get your answer. Okay. Radians per second, because theta per time, per unit time. All right.
Yeah.
Can good. So what do you notice about the theta? Okay, hold on. Let me think. Actually, let me look at the angle. Do you think the angle is increasing or decreasing? As time increases. As time increases, the point moves from the left to right. Decreasing, right? So how come the answer here is positive? Shouldn't it be negative? Was there a mistake in the calculation? I suspect there's something wrong with the calculation. Did they miss out a negative sign? Let me take out my calculator and check. Because intuitively, I would think it should be negatively. Huh. Wait a minute. I sub in. Or am I interpreting this wrongly? Huh. That's weird. Okay, let me think. Angle as the x is decreasing. Actually, let me just draw this diagram first. Wait. Am I interpreting this wrongly? Let me see. As the x is decreasing, so maybe there's a new x here, a shorter x, then that means the point moves up to this step here. Then we get a triangle like this, like this, like this. Then there's an angle over here. That's your theta. New. Okay, this one I don't say shorter x, I just say x new. Is the theta new bigger or smaller?
Bigger.
Bigger, right? Okay. I was wrong. Sorry. It looks bigger. So it makes sense that the theta is increasing. Theta is increasing. That's why it's positive. Sorry for the confusion. I thought it was decreasing.
Oh.
Okay.
Okay.
This angle is increasing. I think it's quite convincing. You can try this triangle, and I think it should be super convincing now that it's increasing. If this is a new x, and then you have this shape here, the point moves up to this step before the A. Okay, anyways, moving on. Any questions actually before I move on?
No.
No? Okay, then last question. Go, 22. Okay, never mind, just go through. Okay, so what we have here is a fixed sphere of internal radius RCM. Then the circumferences of the circular ends being in contact with the inner surface of the sphere show that A square equals to whatever. Here the variable is x, r and pi are constants. Okay, where A is the curved surface area of that cylinder. So basically, when they say inscribed, it means that these sides of the circle, can you visualize that they are touching, they are sort of slicing the sphere horizontally, like a plane?
Yeah.
Can. If you take a horizontal plane and you slice a sphere, then you will get a circle. This is, even though this is 3D perspective, that's why it looks like a ellipse, like an oval, but actually it's a circle. If your eye is at the top and you're looking down, it's a circle. Okay. So prove that if x is made to vary, so x is a variable, the maximum value of A is obtained when the height of the cylinder is equal to its diameter. So where is the height? Okay, let's look at this diagram. Let h be the height of the cylinder. So height is over here. and you want to show that the surface area is a maximum when this h is exactly equal to the diameter. What is diameter? Where's diameter? Diameter of a what shape?
A
Complete the
circle.
sentence. Ah, yes, circle, right? So what circle are they talking about? Must be this circle or that circle. They are the same. So here they denoted the x as the radius of the circle, right? So that means diameter is actually
2x.
Yeah, correct. So that means let's just label this. Diameter means that you have 2x. So what has to be 2x? When the height equal 2x. So in other words, h equals to 2x. Right?
Yeah.
Okay, so just keep that in mind. We have to substitute in, maybe as a last step. Not sure. Let's just explore the diagram first. Let me see first. Okay. Can. So what do we want? Let's write down our objective. Our objective is to find the maximum value of A. So how do we obtain maximum? Definitely need to differentiate, right? So in other words, we need to find dA by d. In this case, it's x is a variable. So dx. And then after that, what do? We equate it to find maximum, we equate this to
0.
0, and then you solve for x. So in this case, if you solve for x already, maybe if you want, you can do a second derivative test. Okay, that's what they did. They didn't request for it. Technically, when they don't request for the test, you don't need to do it. But to be safe, it's better to just do the test, regardless, to confirm that it is a maximum. First or second derivative test to confirm maximum area obtained when x equal to some happy face. When x equals to some happy face. Okay, so what else? We also want to find the value of A. It can be obtained when h is equal to 2x. So from this x, we need to deduce that h must be 2x. But that means that then we have to show that h is equals to 2 times of happy face. Does this make sense? What the question is asking you to do? To get the maximum of A. Okay, the maximum of A is actually not the final goal. The final goal is to show that the height of the cylinder is equals to its diameter in order for you to obtain a maximum value of A. Is the objective here clear?
Yeah.
Let me say again, the entire procedure, the rough outline. So first, you got expression for A in terms of a variable x. You want to find the maximum value of A. How do you do that? Just differentiate, get dA by dx. Then the standard procedure is differentiate, equate to 0, then solve. Maybe I write down des. Differentiate, equate to 0, solve. Differentiate, equate to 0, solve. Okay? Des.
Okay.
Differentiate, equate to 0, solve. Then you get some x equal to some number, happy face. We will get an answer later. So just draw a happy face for now. Then you can do first or second derivative test to confirm that it is a maximum. This is a distraction from the main point. Let's just ignore this for now. It's a distraction from the main point. So after we found the x equals to happy face, what do? We need to show that the maximum value A is obtained when the height h is equals to 2x. In other words, for this happy face value of x, you need to show that h is equal to 2 times that happy face. Is that clear?
Yeah.
This part? But then there's a problem. Why would h be related to x? We don't know anything about the relationship between h and x, right? So that's why at the very beginning of the question, here, they start off by, they already went through this thought process and they realized, oh, I need to have a relationship between h and x. And then later I substitute in x with a happy face value. So that's why we look at right angled triangles and try to deduce a relationship between the h in terms of x. I mean, between the h and x. So we need to find, so sub goal. is to find h in terms of x. Okay, we need to relate the h to the x. Is that clear?
Yeah.
The goal? How do we do that? Typically just Pythagoras theorem. So let's just look at the diagram. Here you can see a hidden right-angled triangle, right? This is radius r of the sphere, which is the same as the radius in this specific right-angled triangle. The hypotenuse, sorry. And then you have a y and you have a x. Actually, what's y? Or why they introduce themselves? Okay, it doesn't really matter. But do you agree that there's a right-angled triangle here?
Yep.
Yes, r, x, and y. Okay. Why you introduce yourself? Introduce yourself. Introduce yourself. Introduce the y yourself into the diagram. And then from there, you can use Pythagoras theorem, and then you conclude y equals to square root r squared minus x squared. Okay?
Okay.
Just make y the subject from Pythagoras theorem. Okay, good. Then now what do we have? H is equal to 2y. Actually, is that accurate? Oh. Yeah, h is equal to 2y in this case, since we already know that the height will be twice the radius for the maximum. So that means that what? That means that in our expression for area, hold on, let me think. Okay, wait, I'm a bit confused. Oh, right, I forgot. There was a show word. I thought it was given. Sorry. You need to show that a square equal to this guy in terms of x square. Right. Okay, so yeah. So how do they get this expression 2 pi x times h? The curved surface area of a cylinder. So you need to understand how a cylinder is formed in terms of its net. So a cylinder is just this shape here. But if you want to find total surface area, what would you do? You have to split it up. So the curvy part at the side, right, it's actually, if you unwrap it, imagine it's like a tin can. It's actually a flat piece of metal, in a rectangular shape. Okay, when you fold it up, then it will become a cylinder, the curved part. And then there's also the lid as well as the bottom that's connected at the end like that. So this is the net of a cylinder. Is this clear to you?
Yeah.
Okay, but now we only want to focus on the curved surface area. That's A if you read the question. So it's just the rectangle. We focus only on the rectangle. Then how do you find the area of a rectangle? Length times breadth, right?
Yeah.
But what's the length over here? It's actually the same as you imagine this part, it must wrap around what shape? It must wrap around the lid, right? So the circumference of the lid. In other words, this length here, the pink color one, is the same as the circumference of the circle, of the top lid or the bottom. Agree so far?
Yeah. So it's 2 pi x.
Correct. That's how they get 2 pi x over here. Then why is there a h? That's just the height here.
The h.
This is the height of the cylinder. H here. Then length times breadth, circumference times height. 2 pi x times h. Clear?
Yeah.
Okay, good. So also we have expression for h in terms of y, 2y, so we sub in. But then what else do we know about y? Y is actually square root r squared minus x squared. So combining, we obtain 2 times square root r squared minus x squared. Is that okay so far?
Yeah.
Then you just multiply the 2 and you get 4. Okay. Then what do we do next? We need to show that it is a squared equals to 16 pi square x squared times r squared minus x squared at the top. So we just have to square both sides. What happens when you square both sides? You have to put bracket, then square, bracket, then square. So here, important point to take note is that you need to distribute the square to all the factors. Because this is multiplication, 4 times pi times x times square root. So you need to distribute the square. So you end up with 4 square, which is 16, pi square, which is pi square, x, you square it becomes x square, Then square root whatever, you square it, no more square root. So far, okay?
Yeah.
Then you can bring the x squared in. So r squared x squared minus x power 4. And then I realized that it's a little bit different from what is shown. Okay, actually here is already shown now. You can stop here, put bracket shown. Okay, then now we can move on to our objective of finding the maximum of A. Okay?
Yeah.
Now, here the question is actually kind to you. They gave you the A square. So even if you couldn't show this, you can continue, right? You want to find dA by dx. The smart way to do it is to work with A square and use chain rule, or what they call implicit differentiation, right?
Yeah.
On the left-hand side, differentiate, you get 2A then times dA by dx. And on the right-hand side is no square roots, which is very, very nice to work with. If instead you worked with A equals to 4 pi x times square root r squared minus x squared, you're going to have a very bad time. You know why? You can find dA by dx directly, yeah, but what's so bad about it? Without the square expression. You find dA by dx. What rule do you need to use? There's an x here, there's a multiplied by a square root x squared minus x squared. So it's a product. You need to use product rule, right? Take one, differentiate the other, take the other, differentiate one. So if you have to differentiate square root, do you know how messy it's going to look?
Yeah.
Half in front, and not square root as a negative half, or you have to write it down as a denominator. And then if your handwriting not nice and you don't want to waste paper, you squeeze everything in between two lines of fraction, you're going to get confused. So on and so forth, right? So here, they were very kind to you. They gave you a square as a hint. Don't deal with the square root. Use implicit differentiation, the left-hand side, and then the right-hand side. Wow, so nice. You see, so easy to deal with. Two separate terms in terms of x. Here's a constant. They brought the x in already. Right? So you just need to leave the constant alone, then differentiate term by term inside the bracket. R squared x squared becomes r squared times 2x. Right, just differentiate the x squared. X power 4, bring down power minus 1, so 4x cubed. Minus just copy down. And then you get an expression. Then you just bring the 2a back in. I mean, back over to the right-hand side. So you divide by 2a. Here they cancel off the 2 with the 2 and the 4. So that's why it becomes 1 and 2. Here the a will cancel off. Sorry, the a doesn't get to be cancelled off. Just bring over. So you end up with divide by a. Is this part okay?
Yeah.
Very good. Then how do you find the maximum? Same procedure, differentiate, equate to 0, solve. So here, okay, differentiation also need a bit of art skills. You need to know that, oh, actually I can square both sides implicit differentiation to avoid complicated product rules. So anyways, now that we have this dA by dx, we just equate to 0 and then solve for x. Do I need to go through this?
Don't
need. So why we reject negative is because x is a length. X cannot be negative. All right. A point to take note over here is that actually they ended up with r squared equal to r squared over 2 or x equal to 0. Here the reason is they decided not to divide by x at this stage. They decided to factorize. So x multiplied by something else. So each factor is equal to 0. And if this second factor equal to 0, you can solve for x and x squared and you get r squared over 2. So yeah, then from there, x squared you split up into 2 halves, plus and minus. Just take note, every time you take square root, you in general need plus minus. Is that okay?
Yeah.
Can good. So x equal r over square root 2. And what was our goal again? After we found our x happy face, this is our happy face.
Like sub back in.
Sub back in, and then you have to show that h is 2 times of happy face. H is 2y. You got x is this guy. How do you? But you cannot sub in directly. You can't sub in directly, right? Because it's in terms of y. So what do we do? What's y? What's y?
Like half of h.
Y is half of no. There's a more immediate, more useful formula right over here. What's y equal to?
Half of the.
Oh, I'm circling. Yeah, square root of r squared minus x squared, right?
Oh, okay. Yeah.
Yeah. So, what a coincidence it is in terms of x. The capital R is a constant, so you can leave it alone. Just bring it along. X square can be replaced with the R over square root 2. Okay? So you can start from here, happy face, sub in into here to get your Y. Then from Y, you sub in into here and you get your H. Okay?
Yeah.
Okay, very good. So that's our goal. But before that, they did something very extra. They go and do the second derivative test to prove that it is a maximum at x equal to happy face r over square root 2. In this case, how they did it, they start off with, if I'm not wrong, they start off with equation 1, then they differentiate. So they use chain rule. Sorry, did they use chain rule? No, they use product rule first. So here are two different expressions. So they have to use product rule, right? Keep the 2a, then differentiate the dA by dx. So you get d2a by dx square. Plus, keep the dA by dx. Hold on a second, something is wrong. Let me think a bit. Keep one, differentiate the other, plus keep the other, differentiate one. Right, correct. Okay, here, how did they get this weird looking expression? It's because they kept the dA by dx, then they differentiate 2a. They kept the dA by dx, then they differentiate 2a. So what happens when you differentiate 2a? You end up with 2 times dA by dx, right? The 2 can factor out.
Yeah.
I'm focusing on this expression here. Right. The first,
Yep.
this whole thing is using product rule. There's a left expression, there's a right expression. So they kept the 2a differentiate dA by dx. Now it's the other way around. They keep the dA by dx, then they differentiate 2a. So if you keep the dA by dx, you have this guy here. When you differentiate the 2a, you have that guy there. But this can be simplified as 2 times dA by dx times dA by dx. That's why they have a dA by dx bracket square. Is this part okay?
Yeah.
Can just product rule on the left hand side. Then the right hand side, you also differentiate with respect to x and you get the following. Can? 16 pi square factor out, then differentiate term by term. Term by term. Good. So now we have the x value r over square root 2, a happy face, you sub in, and then you realize that you will be able to obtain a expression like this. How did they do that? They had to figure out what is dA by dx first. Because what they did is they made d2a by dx squared a subject by bringing this term over and then divide by 2a. So they had to figure out what's the value of dA by dx first. In this case, can you tell me what's the dA by dx value when x is equal to r over square root 2? Think carefully. How do we obtain x equal to r over square root 2? What's the three letter procedure?
The dx is 0.
Very good. dA by dx is equal to 0. So actually here, very simple. This is just 0. Did you see that? Without, it has to be a 0 without actually substituting in. I know there's an expression over here for dA by dx. Please don't go and sub in the x equal r over square root 2. You end up with a 0, which means you're wasting time. You can go and sub in the x equal r over square root 2, but you end up with a 0. Don't do that. Waste time. Right? Because
Okay.
understand? Okay.
Yeah.
So after you sub in, just note that dA by dx must be equal to 0 because of theory, right? Stationary points. So this becomes 0. That's why you can just solve for d2a by dx squared easily by dividing by 2a, which is what they got over here, right? And they replace the x with r over square root 2. Okay, then they simplify this into this. 16 and 2 cancels away. This becomes 1, this becomes 8. What else we have? We got 2r squared minus 12 times r squared over 2. 12 and 2 cancels away. This becomes 6 and 1. Anything else we can simplify? Yes, because this is 2 copies of r squared minus away 6 copies of r squared. 2 apple minus 6 apple gives you negative 4 apples. So negative 4 apples being the r squared. And you have 8 pi squared over 8. Is that okay?
Yeah.
Then you can factor out the negative, or actually just realize that there's a negative. What's so special about 8 pi squared over 8? It's positive. Pi is positive, pi squared will be positive. 8 times pi, 8 is positive. You multiply them, you get positive. Area A is also positive. So positive divided by positive gives you positive. R squared, also positive, right? R is a radius, so it's a positive length. Square, it's still positive. So positive times positive gives you positive. 4 is also positive. So everything is positive. The only one that's causing a problem is the negative sign there. Okay? Everything else is positive except for this one negative. So therefore, the whole thing becomes negative. It says 害群之马. I don't know. Okay, just one. Yeah, so one extra thing that causes it to become negative. Okay, so therefore d2a by dx squared is negative. What does it mean? It means that the rate d by dx of dA by dx is less than 0. In other words, this dA by dx is a decreasing function. It's a decreasing function. What does it mean when it's a decreasing function? It means the only possibility is for you to have a maximum point. So for example, like this, you got dA by dx it's like a thermometer, right? dA by dx is like a thermometer that measures not the temperature, but rather the gradient of the graph at different points. So at this point, there's a gradient. At this point, there's a gradient. At this point, there's a gradient. What happens to your gradient? Positive, 0, negative. Positive to 0 to negative is decreasing. Right? So when we say dA by dx is a decreasing function, we mean that graphically, the tangent goes like this. Positive on the left, 0 on the middle, and then negative at the right. So the only possibility for the curve that has such a measurement, temperature reading, or gradient reading, is for this curve to have a maximum point. So that's how I understand it. If there was too much, don't need to worry. As long as you got less than 0, just memorize it is maximum point. Can? Mic test, are you?
Yeah.
Okay, can, good. So now that we have done with the distraction. The distraction, haven't get to the main point. We have to show that h is equal to 2 times of a happy face. So finally, we know that y is this guy. We can just sub in the expression over here. So h is equal to 2 times square root r squared minus x squared, but the x squared can be replaced with r over square root 2 then square. Or if you're even faster, you realize that just now we already got x squared. Just sub in straight away. It's the same thing. Just square the r over square root 2. And then you simplify, you eventually get to 2x. So we are done. We get back to r over square root 2, which is just x. So we have shown that h is 2 copies of x. Is this okay?
Yeah.
Can? Yeah. So that's how you solve this question. Okay, that's 22. Can we have a short 5-minute break before we continue?
Yeah, sure.
Can? Yeah. Okay, we'll resume after that.
Okay.
mic test.
Yep, can.
Mic test, mic
Hello?
test.
Hello?
Hello, hello.
Hello? I cannot hear anything.
Hello, is the audio okay?
It keeps cutting off.
Is it okay now? I mean,
Now okay, I think. Are you seeing anything?
oh no. I am saying
Cannot hear. I only heard like one word.
problem. Hold on. I am going to and come back. Group won't close down. Mic test, mic test.
I can hear already.
Okay. Right. Okay. Oh, my phone is my problem. Sorry. I think my phone overheating. Yeah.
Oh, no.
Anyways, we covered 22. How about the other parts? The question 23. Is it okay?
Let me
Remember.
see.
I think you take so
Yeah,
I'm
it's
assuming it's
correct.
correct. It's
Yeah.
correct. Okay. Good. Then we can move on. Sequences and series. Yeah, very good. Do you want to recap on sequences and series theory first before I start?
Yes.
Yes, okay, can. Then I'll just add it at the front. Okay, I'll add it at the end. Okay, so for sequences and series, basically you are taking your pattern recognition pattern to the maximum level. Primary school, you learn before this kind of patterns, right? 3, 5, 7. What's the next one?
9
9. Why? What's the pattern?
is +2.
+2. Yes, you already know this, of course. But the key trick here is to realize that whenever you +2, it's a fixed number. This is what we call D, the positive constant difference. Okay. And who's the first value? Who's the first value in this sequence?
3.
3. So this is our A value. Then what's the generic pattern? We can sort of draw this inside our table like this. We've got N and a Tn, or sometimes we also use U and subscript N. I'll just use Tn for now. 3, 5, 7. Oh, sorry. That should be at the bottom. 3, 5, 7, 9. This is 1, 2, 3, and 4. So we want to find a generic formula for the nth term. ... And then we get the nth term. What is the formula here? How do you form it?
N minus 1D.
Yes, correct. This is also known as a arithmetic term. Okay, sorry. Term in an arithmetic sequence. Okay. What's the difference between sequence and series? Sequence is a list separated by commas. Separate with commas. Okay, so this is a sequence with a fixed common difference. Then what's a series? Or the sum of a series. A series technically is a formal expression that has no value. But okay, don't need to think so hard. Just think of it as a sum. Sigma notation. It's the sum of all the terms.
Oh.
If I put down like let's say I equals to 1 to n, then it means so maybe I'll be more specific. Of I don't know, 3 plus n minus 1 times 2, like this. It means it's the sum of the first n terms. Okay, sum of the first n terms. So let's think about it. So yeah, we got the generic expression Tn equal to a plus n minus 1d. So in this case, your Tn is actually 3 plus n minus 1 times the common difference of plus 2. Is that okay? In this case, that is arithmetic sequence. Now we move on to arithmetic series. Okay, later then I talk about geometric. Is that okay?
Yeah, okay.
So for arithmetic series, now basically we're asking you, what is the value of 3 plus 5 plus 7 plus 9 plus? Okay, let's just stop at 9. Of course, you can use a calculator, but that would be a bit too slow once this goes into 900 or something. So we need to come up with a general formula for it. How do we do that? Here's how we do it. Here is a very clever guy who came up with this idea. The story is like he was punished in class. Then he was asked to add up all the numbers from 1 to 100. And he managed to do it in like 30 seconds because he know the trick. What's the trick? The trick is to call this as the answer we want to find. Maybe I'll call it S4. Why 4? Because 1, 2, 3, 4 times. Then I draw S4 again, but this time I reverse the order. 9 plus 7 plus 5 plus 3. Okay, what happens if I now add those two copies together? S4 plus S4 gives me 2S4. But if I add them, I can also add column wise, right?
Yeah.
What's so special? What's 9 plus 3?
12.
What's 7 plus 5?
Oh, 12.
What's 7 plus 5 plus 7? What's 7 plus 5?
12.
Okay. What's 9 plus 3?
12.
Oh, magic. Of course, it's not magic. It's gonna happen. Gonna have 12 appearing how many times?
4.
So 12 times 4. Oh, a general trick here.
Oh.
Then how do you solve for S4 now? 12 times 4 divide by 2. And this is, if I rephrase it, it's the same as half multiplied by, sorry, let me rephrase it like this. 4 over 2 times 12. Correct or not? Maybe it's neater if I do it this way. 12 plus 12 plus 12 means, however many times means there are 4 copies, so 4 times 12. And then 4 times 12, you divide by 2. So I rewrite it like this, 4 over 2 times 12. Is this okay?
Yeah.
Can, but you can always rewrite it as 4 over 2 times 12. But how do we obtain the 12 in the first place?
The sum of the two.
Of 2 of them, right? Either of them, right? Either of them. This is what we call the A. This is what we call the A plus n minus 1 times d. Correct? The nth term.
Yeah.
The last term, and the first term. Okay? So the easiest way is to always take the first term 3 plus the last term. Of course, equivalently, you can take the second term and the second last term. Third term and the third last term. Fourth term and the fourth last term, which is the first term. Fourth last term is the first term. Does that even make sense? Okay, you get it, right? It's basically first and last, second and second last, third and third last, fourth and fourth last. They are all equal to 12, but don't make things so complicated. Let's just pick the easiest one. First term and last term. Is that okay?
Yeah.
The last term is the same as nth term. Is that okay?
Yeah.
And the expression for nth term is always a plus n minus 1 times d. That formula there. So that means we can always rewrite this 12 as first term plus last term, which is, can split as 3, 9, right? 3 plus 9. But how do we obtain 9 in the first place? By using the formula here, but you substitute n with 4, right? So T4 equals to 3 plus 4 minus 1 times 2. Do you agree with this one?
Yeah.
Oh, you can think of it like just to help you. I don't know. You're starting off with a number line. Here's 0. Then here is 3. And then what happens is that you are considering how do you get to 9. You just need to plus 2, plus 2, plus 2 3 times. Right? That's why, because there's plus 2 3 times, that's why we have to plus 2 times 3. But 3 in this case is 4 minus 1. And you start off with a original value 3. That's how we get the formula. Does it make sense?
Yeah.
You're taking the constant difference here, D, is like imagine like a rabbit at position 3. And it's hopping 2 steps at a time. 2 steps at a time. 2 steps at a time. And we're counting how many times did he jump and travel 2 meters or something. 2 meters, 2 meters, 2 meters. And how many 2 meters does it need to travel in order for you to start at 3 meters from the origin to 9 meters from the origin? Yeah, okay, that's a physical analogy, huh? But generally, it's just first term plus n minus 1 times d. Okay, but anyways, why did I want to write it down as 3 plus 9? Because 9 can be further split as
3
first
plus 3
term
plus 3.
plus n minus 1, no, 4 minus 1 times the common difference of 2.
Oh.
Yes, it's 3 plus 3, but that's a general way. And that means that I can rewrite this as 4 over 2 multiplied by first term plus last term. Okay?
Okay.
Why did I purposely write it in this way? Because I need you to remember the general formula, which is? Recite for me, what's the formula?
The n over 2 bracket 2a plus n minus 1d.
Correct, 2a. Yes. But I like to remember as first term plus last term. And it just so happens that both of them got a and a, that's why it becomes 2a. Is that okay?
Yeah.
Can that is arithmetic series. So it's a magic formula that helps you to add up all the numbers straight away. So another way that you can interpret this, the geometric picture for this is like, for example, what is 1 plus 2 plus 3? Obviously it's 6, but but it's actually the same as 3 times 4 over 2. Sorry, 3 times. Yeah, correct. How do we interpret that? You can draw a picture like this. Staircase. Okay, maybe I'm trying to make it more accurate. Okay, staircase. But then you can reverse the staircase. So you can have something like, how do I draw it? Like this, and then like this. Can you see?
Okay.
So I took the staircase, I flip it upside down, and then I join them together. What shape do you get here? What shape do you get here?
A rectangle.
Rectangle. So how many chocolate? How many pieces of chocolate are there in this chocolate bar?
4 times 3.
3 times 4, which is 3 plus 1. Then how do you get one such half of this chocolate bar only?
Divide by 2.
Just divide by 2. So that means your answer to this will just be 3 times 3 plus 1 divided by 2, which is what we have over here. That's the intuitive way to remember the formula. But is it useful? I would say actually not so much, because this only this pattern only works when the common difference is plus 1. You need to H2 max cannot rely on this simple pattern anymore. You need to use the generic formula. Is that okay?
Yeah.
Can another thing about arithmetic sequence is that there is what we call the common difference. In other words, whenever they tell you that there is for example, there's A, and then there's B, and then there's C, are the first, fifth, and seventh terms of an arithmetic sequence. Then the question is to express B in terms of A. B in terms of A, and likewise express C and this is part 1. And part 2 is express C in terms of A. Can you try? Part 1. First, fifth, and seventh, right? So first, fifth, seventh. What's the formula again? Tn equals to?
The n over 2a plus n minus
No,
1d.
no. Tn. That was Sn. That one was Sn. This is Sn. Sorry, I forgot to write down. Summation. S for series. No. I'm not asking for term. Tn.
Oh,
This guy.
Tn is the un.
Un. Yes, correct. It's the same thing as un.
Oh, is the a
Same
plus
thing.
n minus 1d.
Very good. A plus n minus 1 times d. In this case, oh, right, I didn't give the difference. Okay. Wait a minute. I give you difference. Common difference being, I don't know, what number would you like?
2.
Okay, 2. So D equal to 2 lah, basically. Then express B in terms of A.
Is a plus 4 times 2.
Yeah, 5 minus 1 times 2. Okay, how about C?
Is a plus 6 times 2.
Very good. Yes, correct. Okay, good. So you get this idea. Then good. Okay, then that's pretty much it for arithmetic sequence and series. Moving on, Ken?
Yep, can.
Geometric sequence and geometric series. So it's the same thing again, but this time instead of plus, it becomes
Times.
Times. Now take note that the value that we add can actually be just now, right? Plus. It doesn't always have to be plus. It can be minus. So minus 3 is also possible. And it doesn't have to be whole number. It can be minus half. Likewise for geometric sequence, you can times. You don't have to be whole number. You can also be fractions. So let's say start off with an example like 3, and then times. Why did I pick 3? Can I just pick a smaller number? 2. Then times 3, and then times 3, and then times 3, and I think I should stop there. Let me just check with my calculator first. Okay, I'll just add one more. 162. So the pattern here is times 3 times 3 times 3. Is that okay?
Yeah, can.
Now, can you find the generic term? A is equals, this is A. Then the common instead of D for difference, now it's common what? Common?
Factor.
No. Factor can also. Ratio lah. I like to call it ratio. Okay? Common ratio. So let me just increase the thickness. So R equals to what?
3.
3. Okay, good. Then what else we have? N. N for number of terms. Nth term. Nth term. Let's just denote it as let's say UN. Okay, UN. What would it be?
The AR to the power of n minus 1.
Very good. N minus 1. Yes. So in this case, it will be 2 times 3 to the power of n minus 1, right? So you can draw a table. So that means that you have n and un. So 1, 2, 3, 4, 5. U1, U2, U3, U4, U5 being 2, 6, 18, 54, 162. Okay, good. So that is geometric sequence. Sequence means separated by commas. And we got the generic term. Why is it always minus 1? It's just the pattern lah, Because you see, second term, you have to start from 2, you times 2, how many times? 1 time only. Then let's say 54, how do we get 54? We start with 2, we times 2, 3 times, right? Even though it's 4. So that's just a fixed pattern, always minus 1. Can you accept this? Can, good. So now with that convention done, the index always starts from 1. Always starts from 1. All the time. At least for H2 max. Now we move on to geometric series. So geometric series is basically asking you, instead of finding out a specific term, right? Okay, actually, how do we get 54 using a formula? Let's just do it quickly. U, for example, only is equals to, sorry, I go back to geometric sequence first before I move on. So 2 times 3 to the power of, in this case, 4 minus 1. You'll get 54. Is that okay?
Yeah, can.
I mean, n equal to 4. Okay, now moving on to geometric series. For geometric series, we're basically asking you, if we add up Sn, meaning up to n terms. What's the fancy formula for it? Let's do an exploration. Let's say we want S5 in this case, which is 2 plus 6 plus 18 plus 54 plus 162. Of course, you can use a calculator to key in manually, but the main point is that it is a bit too long-winded. If the number becomes 1000 whatever, very, very big, then it's impossible. So we need to come up with a formula for it. I'll just show you how to get the formula for this case, and I'll go a bit quickly. Basically, you need to realize that the pattern here is times 3 times 3 times 3. So I can take this S5, I multiply it throughout by 3. So what happens? 2 times 3 gives me 6. 6 times 3 gives me 18. Then I plus. So basically, it's shift forward by 1 position. And likewise, for the 18, you can also shift forward by 1 position, and you end up with 54. Is that right? Yes, 54, 162, and then finally, why is 162 times 3? 486. I'll just draw in the arrows so you can see it clearly. Can?
Okay.
Clear? Good. So now you got 3 times of S5. What do we do next? How about if we take big minus, top minus bottom. This is equation 1, this is equation 2. What if we take 1 minus 2? What happens? We have 1 copy of S5 minus away 3 copy of S5. So I'll purposely write it as 1 minus 3 times S5. I know it is negative 2, yes, but I don't want to write it because I need you to see the general pattern. This is 1 minus R. 1 minus R, sound familiar? Hopefully, the formula. Keep thinking inside your head, why got 1 minus R? Or in this case, 3. What happens if you subtract now? Let's take a look. If this was chemistry, I think balancing equations, right? What happens when you have top and bottom, they are same? And you minus?
Yeah, they cancel out.
They cancel out. So everything in the middle will cancel away. You're only left with 2 minus 486. 486. Is that okay?
Can.
Can, let's just bring it together like this. So how do we get 486? Let's think about that later. So how do you solve for S5 now? 2 minus 486, you just have to divide by 1 minus 3, right?
Yeah.
Okay, very good. Then there we go. That's a formula for S5. It's the same. So let's just key in manually 2 plus 6 plus 18 plus 54 plus 162. It's actually 242. This is actually equals to 242. But this formula will also give you 242. You want to try with a calculator to convince yourself?
Okay.
This whole chunk and this fraction, both are 242.
Yeah.
Can, yeah, so my formula works. But now, okay, let's just throw away the 242. But how do we generalize this formula? You notice that 2 is just 2, okay? But you minus away, maybe I'll purposely write it as times 1. Then minus away 486. How do we get 486?
It's the last term.
Yeah, is it the last term? There are currently how many terms? 5 terms. This is not the 5th term. This is not n equal to 5. Not wrong. This is n equal to 1, 2, 3, 4, 5, 6. It's the 6th term. It's the 6th term. Agree or not?
Oh, yeah.
So if this is up to the nth term, this is actually the n plus 1th term. Which means that in your formula, a r power n minus 1, the n gets replaced with n plus 1. So n plus 1 minus 1 gives you n. Or actually, don't need to think so hard. This one is an actual number. You just have to think of it as what? 2 times common ratio 3 to the power of what? 1, 2. Barney hop how many times? Hop 1 time, 2 times, 3 times, 4 times, and then 5 times. So power 5.
5.
All over 1 minus 3. Simplify a bit more. Let's see what happens. I realize common factor 2 times 2 times, factor out the 2 times. You're left with 1 minus 3 to the power of 5 all over 1 minus 3. Does this look familiar?
Yeah.
In general, what's the formula? Sn equals to?
It's the a bracket 1 minus rn bracket
N.
over
Good.
1 minus r.
Very good. Yes. Okay, yes, that's a formula you should memorize by now. Okay, that's how you derive it. Of course, in general, when to get the nth term, you have to extend this all the way to, instead of 5, you have to consider 6 or 7 or 8 or all the way. You don't need to know how to prove it. That's for further math. Just need to know the formula and memorize. Is this clear now? Series?
Yeah.
Okay. And then that is the formula. So let's just summarize all the formulas we have. So maybe I'll, oh wait, sorry, give one example first before I summarize. So example, if I tell you that the first, okay, let's say we have a geometric series, geometric sequence such that the first term equals to A, the common ratio is equals to 5, and how do I say it? Can you find for me the first term? And let's just denote it by UN, n being the nth term. Can you find for me U1?
Is A.
It's just A. How about U7?
Is A 5 to the power of 7 minus 1?
Yes, correct. Okay, and then how about U, let's say 8?
Is A times 5, 8 minus 1.
Minus 1. Okay, let's say that these three terms are the exact same as the arithmetic sequence whose first term, let's call it Tn, whose first term is equals to A as well. Then the difference is, I don't know, let's say 7. And what's the U1? Sorry, T1?
Is the A plus.
And T1 is first term.
Oh, it's just A.
A. How about T, let's say 5?
Is A plus 5 minus 1 D, which is 7.
Which is 7, so times 7. Okay, good. And then let's say we got T, I don't know, T10.
Is A plus 10 minus 1 times 7.
If they tell you that the first 7th and 8th terms of a geometric sequence are the same respectively as the first, 5th, and 10th term of a arithmetic sequence, what you're supposed to do is to identify those terms, then just equate them. Is this clear?
Yeah.
If they told you that. Okay. Then what else do we know about geometric sequence? The ratio must be a ratio R, right?
Yeah.
Okay. How about if I rephrase it now? Let's say I'll give another example. Let's say that you have this same arithmetic sequence, and then I tell you that the first, 5th, and 10th terms of that arithmetic sequence are consecutive terms in a geometric series. What does that mean? Sorry, geometric sequence, not series.
Like can equate them together, like the
How?
T1 equals to the
Let's just say ratio equals to R. What does consecutive terms in a geometric sequence mean? It means it's some geometric sequence, then you times R, you get the next one, times R, you get the next one. And they happen to, what are the boxes? They are the first, 5th, and 10th terms. In other words, T1, T5, and T10. Can you form an equation from this information first? T1 equals to T5, but you need to times. Is it times R here, or is it times R on the left?
Is times R on the left.
Yes, correct. So T1 times R. But in other words, you can also rephrase it as T5 divided by T1 equals to R. Agree? Yes, T5 over T1 equal to R?
Yeah.
Can likewise, let's say that we have this T5 to T10. We say, well, can you form another equation? R equals to what?
R equals to two.
No, this is just an example. Sorry, I pick more random numbers. Okay. 10, 11, this is 110. 11 equals to 110 divided by 10. I'm just giving you an analogy.
Oh,
So R equals to what?
the T10 over T5.
Yes, correct. Okay, but then we know the formula for T10 and T5, right? So let's just put it down here. T10 was the 10th term of our arithmetic sequence. So we got the formula there. We can fill in the blank. A plus whatever 10 minus 1 times 7 divide by A plus 5 minus 1 times 7. Likewise, over on the left-hand side, we got what? T5 is, let's just write it like this vertically so I have more space. Likewise, on the left-hand side, we got R equals to T5 over T1, which happens to be just A plus 5 minus 1 times 7 divided by T1, which is just A. But both of them are equal to
Like each other. Like
each other, yes. Equal to R, and they are equal to each other. Very good. So that means we can just equate them together. A, what do you notice? This is an equation that's in terms of what variable?
A.
Then from there we can solve for?
So for A.
So for A, exactly. Do you get the idea now?
Yeah.
You get this idea? They are equal. You can solve for A. I never checked if it actually can be. Is there a solution? Later, I get a quadratic equation with no real roots. Then I'm in trouble. I haven't checked the question yet. Sorry, might be impossible. Can solve for A, but that's the general idea, lah. With that in mind, okay, should I talk about index shift? Okay, I'll talk about index shift. Yes. So let's say this is arithmetic series and geometric series. Then there's also the application to the finance questions where you draw a table. I'll talk about index shift later. Table questions. Okay, yeah, table questions are finance. Usually financial math. Basically, the key trick is your setup of the table. You must have a start, you must have an end, you must have an index. 1, 2, 3. And then the key trick is sometimes you need to leave blank and then you start here. Sometimes you need to leave a blank. Alternatively, you just start straight away. Don't leave a blank. These are the two possibilities. Must read the question to figure out. And also, don't simplify. Don't simplify. Get a general pattern because the goal is to get the ... nth term. The goal is to get the nth term. Okay? Maybe usually this guy. Then this part here, if you're fast enough, you can just skip the nth term for the start. Just focus on nth term for the end. Don't simplify, get a pattern. Okay? This is very important. Don't simplify. That's a table question. The general advice, always have a start, have an end, and the index number. Then you might have to leave a blank space. Sometimes you can leave a blank space if you're fast enough. And then you must fill in the ticks. But the ticks, you need to make sure you don't simplify so you can see a pattern. What kind of patterns will there be? Arithmetic, geometric. As for sequence or series, usually series, okay. And also you need to know about compound interest. P equals to principal times 1 plus, total amount A is equals to principal plus and times 1 plus R over 100 to the power of n. Typical formula, but actually more generally, it should scale the rate and the period. This one should be the interest rate per compounding period, then n should be number of compounding periods, and you have to scale accordingly. Okay, that's table question. Now let's talk about the next one, which is index shift. So let's say that we have a summation like this. I'm sure you know how to do sigma notation, right? We already went through before.
Yeah.
Sorry, I'm using I. Maybe I change to n. N as a cube times n plus 1 over n plus making it so complicated for what? N minus 1 square like this. Okay. Now, if I rewrite this as I don't know, n minus 1 cube, and then n minus 2. If I want it to be equal, right? N equals to question mark and question mark. Let's call it A and B. What is my A? What's my B? Can you see the pattern?
Like n minus 1.
No. What's A? What's B? You start with a 1 and a 5. What happens? Oh, sorry. I cannot. Let me just change this to a 2. Because there's an n minus 1 there at the bottom. Think about it. If you sub in n equal to 2, what happens to the value here? 2 cubed times 2 plus 1 over 2 minus 1 square. Here, what did I do? I rewrote it as n minus 1. In other words, n becomes n minus 1. N plus 1 becomes n, reduced by 1.
Reduced by 1.
This one also reduced by 1. So what is my A? What's my B? How does it link to 2 and 5? Is it still 2 and 5?
So A is 3.
Yes, and
B is 6.
Yes, correct. 3 and 6. Yes, good. How can we see that? Here's how we could do it. You could think of it like this. I didn't show you this last time when we were doing EJC. I just asked you to sub in manually. I guess that's my fault. I should show you the generic method. So basically, here's how you do it. You can think of it like this. Substitute n with, or don't say sub, say replace. Replace n with n prime, in this case, maybe minus 1. Yeah, n prime minus 1. Okay, what happens when we do that? So I copy and paste this expression. Everywhere that had an n, I'm going to replace it with what? N prime minus 1. So n prime minus 1 here. Everywhere that had an n, replace with n prime minus 1. Sorry, the prime there, I hope you're not confused. It's just to make it different from the n. Okay?
Yeah, okay.
What happens when you do that? Let's simplify the expression now. This summation, right? We express it in terms of just n prime. So what will it be? Bring over, it becomes minus 1, bring over becomes 3. Yes, 2 plus 1, 3. Then what happens over at the top? Here is actually also n prime minus 1. But please don't write this during exam. This is non-conventional notation, but it's basically telling you n prime minus 1 equal to 2, equals to 3, equals to 4, equals to 5. Maybe I write it down like this as a table. N prime minus 1 is 2, 3, 4, 5. So now what is n prime?
It's 6.
It's 3, then 4, then 5, then 6. But in summation notation, we never write the in-between numbers. We focus on the start and the end, so it's just a 6. Is it clear?
Yeah.
Can Then how about the expression inside? Just simplify. What happens? n prime minus 1 plus 1, I can cancel away these two, right? Cancel away.
Yeah.
M minus 1 and minus 1 actually not. They don't cancel. They become minus 2. Okay, minus 2 is minus 2 like this. Is it okay?
Yeah, can.
Can. Very good. So let's just bring the bracket back in. And then you realize something. Don't they look exactly the same almost?
Yeah.
Just that n is n prime, right? Then it doesn't matter because here n prime is what we call a dummy variable. N prime is dummy variable. The purpose is just for it to be replaced. It's just a placeholder. When n is the 3, is a 4, is a 5, is 6, you put in. But that means that we can always bring it back to that value. They are equal. Okay, it's equal. Okay, maybe I should just write down exactly equal to the exact same thing, but you replace the dummy variable n prime back with a normal n. So you just remove the prime. Remove, erase, and then we are done. So the value of a and b will be 3 and 6. Okay? Right. Can you do this in like 3 seconds? Practice. Maybe can. Maybe cannot, then just type in manually. Okay. I explained before in the EJC tutorial notes explanation. Okay, that's called index shift. I call this topic index shift. See, the index just shift by 1, become 3 and 6 plus 1. All right, can. Moving on. Now we can start the question. Okay. Cannot talk too much. Okay. I placed it at the bottom of your worksheet. Later I send you the PDF. Okay, let's take a look. So an arithmetic series, there's a first term a and a common difference d, where a and d are non-zero. The first 3 terms of a geometric series are equal to the 9th, 5th, and 2nd terms of the arithmetic series. Let's take a look. So you got un equal to a plus n minus 1d. That's a arithmetic. Good. Then we have the 9th, 5th, and 2nd. So a plus 8d, 4d, and 1d. Good. What else we know? We know that they are equal to the first 3 terms of a geometric series. So that means that this is the first, the second, and then the third. So the ratio must be times r times r. Okay, so that means that you have 8 plus 8d divided by a plus 8d divided by a plus 4d. That's equals to 1 over r. Not r, it's 1 over r. Then you take a plus 4d divided by a plus d. That's also 1 over r. Okay, so they're both equal. Good, this is fine. Then you just have to solve for a and d. Here, even though there are 2 variables, actually it can be solved. For both variables can be solved. Yeah, I think so. What else? Well, part 1 asks you to prove that the geometric series is convergent and find in terms of a the sum to infinity. Right. In terms of a means what? Means you probably cannot solve for a. A cannot be found. So the only unknown here is the d, right? The difference. Okay, so just keep that in mind. You don't need to solve for a, just solve for d, maybe. Or maybe you don't even need to. Because all you need to do here is to prove that geometric series is convergent, which also means summation, absolute value of r is less than 1. And that's when I realized I forgot to mention one topic. Can I just go back to the theory? Infinite geometric series, right? S infinity, not this topic. S infinity. What is it equal to?
The a divided by 1 minus r.
Okay. So some applications of this would be, let's say you want to find the sum from n equals to 1 to infinity of, let's say, 5 plus n over, actually, let's not make it too complicated. Let's say we have 5 minus n like this. Do you know what is this? Okay, I add a page first. Hold on a second. Okay, can you go faster? Okay, this is a sum to infinity formula. It's a over 1 minus r. Basically, this requirement, a requirement for you to use this is the modulus of r must be less than how much?
1.
1. Yes, it's a requirement. You need to know this. So it's a absolute value inequality. Also, you need to learn you need to know how to solve this. Like for example, if modulus of x minus 1 is less than 1, it means negative 1 is less than x minus 1 less than 1. Then you can just add 1 to both sides, you get 0, 2. Okay. Anyways, let's say we got this sequence here with an infinity at the top. What does it mean? It means you want to take the limit as you take the summation of n equal to 1 to, let's say, Okay, I don't use N. Let me just change this to a what's another good letter to use? Let's say I use I. Okay. Change the running variable. We call this the running variable. Did I not mention this? Sorry. Running variable. It keeps running, runs from 1 to infinity. I go to 1, I go to 2, I go to 3, so on and so forth. Let's say we stop at a letter N here, and then we take the limit as N goes to infinity of the same expression. This is equivalent. Do you understand what is the idea of limit, roughly?
Like the maximum.
Not exactly maximum. Okay, kind of. Basically, it goes all the way to infinity. A value that's larger than everything else. Larger than everything else. Okay. But basically, how do you even find out the value to this expression? What you can do is a few things. First, you realize that I is a variable that's degree 1, right? Power 1. So this is a proper or improper fraction. I can think of it as 5 minus x over 1 minus x. Is this proper or improper?
It's improper
Why?
because the degree like is the same.
Degree is the same, then it's improper. Yes, correct. When the degree of the numerator is larger than or equal to the degree of the denominator, then it will be improper. If the degree of the numerator is strictly smaller than the degree of the denominator, then it will be proper. Should I write this down?
Yeah.
Degree num and degree denom. Let me just draw it as a table. If their relationship is, okay, how should I put this? Just write it as 3 separate lines. If it's strictly less than, then it means it's a proper. If it is more than or equals, it will be if it is more than or equals, then it will be improper. More than or equals, either case. So in this case, degree 1, so it's improper. So we can do long division. One way is long division. But that's a bit long-winded, so I don't want to do that. Instead, I'm gonna consider this pattern here. Limit as n goes to infinity of summation I go to 1 to n. But this guy I can split it out as phi over 1 minus I plus negative I over 1 minus I. Okay?
Okay.
Can? Good. So maybe if I is confusing, let's just change it to x. Let's just change it to x. Everywhere that had a I, change it to x. Everywhere that had a I, change it to x. Everywhere that had a I, change it to x. Okay, then now how do we deal with this? DIY, do it yourself. Okay. Yeah, what was I saying? Right, I want to evaluate this expression. So how do we do with it? What we need to realize now is that limit as n goes to infinity of this first sum. You can split up the sum into 2 parts. Summation of the first guy plus the summation of the second guy. Right? So what you realize is that the summation of the first guy, they are both under the limit, right? So you can actually split it up. You can actually split it up into the limit of the first guy plus the limit of the second guy. Is that okay? It's a bit like differentiation. D by dx of 2 terms, you can split it up, sort of distribute the derivative. Okay, then what is this guy? This is really just a what series?
Like arithmetic series.
Arithmetic. Oh wait, sorry. Actually, I realized I made a mistake here. Probably made it too complicated. This is a bit too difficult. You can't really solve this. I was thinking of a geometric series already.
Oh,
Wait a minute, let me think a bit. Oh, sorry. Yeah. Can I just remove this whole thing?
oh, okay.
Sorry. Oh no. This is bad. This is bad. This is a bad example. It's too difficult. Let's say I have the sum to infinity of r. In this case, let's just make it half power r. And then we just plus 3. Okay, like this. And r goes from 1 to infinity. That's not good. You can't have the 3 there. Okay, I'll just leave it alone like this. Maybe plus 1 over. Oh, cannot, it's a sum. Let me think heavily. Okay, this is all. Yeah, just half power r. What is this equal to? This is actually just the same as limit as of the summation from i equal to 1 to infinity. Oh, sorry, to n. And you take the limit as n goes to infinity of half power r. This is actually just a infinite geometric series, right? Yes, no, yes.
Yeah.
Right, because it's half power r, so it's half power 1 plus half power 2 plus half power 3 plus half power 4. So it's times half times half times half. First term is half divided by 1 minus the common ratio. That's your answer. Okay, that's all I wanted to say. Okay, sorry, being too long-winded. Is this okay? Using the formula?
Yeah.
Can Okay, I think that should be good enough. We can move back to the question already. Infinite geometric series. Not this worksheet. It's above. Okay, so anyways, yeah, so when we want to prove that the geometric series is convergent, right, all we need to do is to show that the modulus of r is less than 1. In this case, what is the modulus of r? Modulus of r is actually just modulus of you decided to take the a plus ad over a plus 4d, so it's the other way around. Huh? You have to flip it around. It's a plus 4d over a plus 8d. Equivalently, it's the modulus of a plus d divided by a plus 4d. Okay?
Oh, but why?
Because it's the first 3 terms, so it must go in order. This guy is the first of the geometric series. This guy, the 5th term, is the second. The 2th term, second term, is the 3rd term of the geometric series. That's what they mean when they say are equal to. Okay? Can?
Oh, so it must be like the 3rd over the 2nd.
In order for you to form R, yes, in order for you to form the R. But here, since it's just an equal sign, you can equip. What you did was you found 1 over R. You found 1 over R. And they are both, you made the same, it's not a mistake. It's okay. Both of them are equal to 1 over R. So you can still equate them. Nothing wrong. Up to this step is fine. It's just that our end goal is to show that modulus R is less than 1. So I decided to find these guys. So either one is fine now. Later we need to figure out that this fraction we need to show is less than 1 or that fraction is less than 1. Okay, that's our end goal.
Okay.
The end goal. Ooh. Okay, moving on. So now we have this expression. You can cross multiply. So that one go there, that one go there. You're left with a plus 4d bracket square equal to a plus d times a plus 8d. That is fine. Then after that, you expand out the square. So a square plus 2 times a times 4d ad plus 4d square is 16d square. Good. Multiply this out, you get a times a square. A times ad is 8ad plus d times a is 1ad. So add together, get 9ad plus 8 d square. This is fine. A square, you realize that they cancel each other off. Then you're left with 8ad, 9ad. They can also cancel away each other. 8 copies gone. You're left with just 1 copy of ad. Then you're left with 8d square plus 1ad equals to 16d square. What else do you realize? Oh, you realize that 16d square and 8d square can also cancel off. So this guy is gone. This guy becomes 8. So you're left with 8d squared equals to 1ad. You bring it over, so minus ad. Then you factor out d, left with d times 8d minus a. So the first factor or the second factor equal to 0. So difference cannot be 0. Very good. If not, the arithmetic series cannot exist. So you reject the answer. So 8d minus a equal to 0. You're left with this guy. Then our goal is to find what? show that the modulus R is less than 1. So either of these fractions are less than 1. So now that we know 8D equal to A, we can actually figure out what is, let's just use this fraction. 8D is equal to A, so that means that 4D is equal to half A, right? Then just substituting in, we get modulus R to be equal to modulus of A plus 4D being half A, divided by A plus 8D being single A. We can simplify this expression, so we get 1.5A on top and 2A at the bottom. What happens to your A?
They cancel out.
Cancel out, so 1.5 over 2. Modulus, this is of course less than 1. Therefore, convergent. Okay?
Yeah.
Can okay, good. So that is part 1 done. Now, given that A is more than 0, and also it's fine because we know A is not non-zero, so we have no issue with cancelling. If A was 0, then there will be a very big problem here. We are dividing by A. Okay, anyways. Part 2, given that A is more than 0, find the largest value of n for which the sum of the first n terms of the geometric series is less than 4/5 of the sum to infinity. So there's a few things we need to deal with here. Sum of the first n terms of the geometric series less than, so we need to form our inequality, 4/5 of the sum to infinity. That's number 2. Let's deal with number 1 first, the sum of the first n terms. How can we find the sum of the first n terms? You paste it on the same page. Can you next time when you do questions, right? Since you're using an iPad with infinite paper, can you always start a new page on a new paper? If not, a bit difficult for me to insert page. I have to insert page into it will disrupt the flow of the paper. Do you understand what I'm saying?
Yeah, can.
Right. Can yeah, now I'm just gonna insert page and disrupt the flow. No choice, because I have no space to write. Okay, anyways, what was I saying? I lost my train of thought. Right. Part 2. We have part 1 and part 2. We need to find part 1 first. Find part 1 first. Find the sum of the first n terms of the geometric series. So now that we know the expression for R, right? It's actually just 1.5 over 2. Let's just actually figure out that value. 1.5 over 2 is what? 1.5 divided by 2. I don't trust my brain. Just use a calculator. It's 3 over 4. Okay. R is 3 over 4. Okay, R is 3 over 4. Then we can use that to help us to find the geometric series. We know do we know what is A? Do you know what is A?
No.
No, we don't. So that means that we have to continue using the A. Okay? So continue using an A, and then we try to figure out what is that geometric series. So let's take a look. Some of the let me think a bit. The first term of the geometric series, is it A? Right, because you see, what I'm trying to do now is to find the sum of the first n terms, and the formula is what? A times 1 minus R power n over 1 minus R. First term multiplied by 1 minus the common ratio raised to the power of number of terms, or divided by 1 minus the common ratio. A is first term, but that is the generic formula. Is the first term of the geometric series also equal to A? Yes or no? Or don't know?
It's not.
It's not actually. The first term A only applies to the arithmetic series. Okay. Actually, technically, they should have said sequence, not series. So it's a bit inaccurate in the phrasing. But okay, fine, whatever. First term of the geometric sequence is actually the first term of arithmetic series and sequence is the same. Sorry, they were accurate. Okay, anyways, first term of geometric sequence here is actually the same as which term of the arithmetic series? Sequence. Read the second sentence. The first
three terms.
Read the whole sentence.
Oh, the first three terms of a geometric series are equal to the ninth, fifth, and second terms of the arithmetic series.
So who is the first term in the geometric series the same as?
The ninth term of the
ninth term.
arithmetic.
So A equals to the ninth term of the arithmetic series, which is equal to A plus 9 minus 1 times D, right?
Yeah.
Very good. So what do we know about A, Y, and D? Let's just 8D. Well, we don't know A, right? So we need to figure out, but at least we know what is D. What is D? Or maybe we don't know what's D. We know something related to D. Over at here. 8D is A.
Is A.
8D is A, so that means that 8D here is?
Is A.
So this simplifies into 2A.
2A.
Okay. Can 2A. So that is your first term. So now that we have the what do you call it, the first term, we are good to go. We just need to sub in only. The R and the N can just leave alone. Okay. Our 1 is done. Let's just fill in the blank now. 1 is actually just Sn equals to first term. It's not A, it's 2A, but you multiply by 1 minus common ratio, let's just call it R. Power of number of terms. Here we are summing out the first n term, so power n divided by 1 minus the common ratio. Take note that the A here, the R here, and the N there is not always literally a A and a R and an N. You need to contextualize, okay? In this case, A is not A is 2A. But the rest are still the same. Okay, 1 done, 50% done, 50% more to go. How do you find number 2? The 4/5 of the sum to infinity. 4/5 times S infinity. So it's 4/5 times what? What's the formula for S infinity?
The A divided by 1 minus R.
Contextualize what is A. A is the first term. So is the first term still A in the matrix? What's the first term?
2A.
It's 2A, not A anymore. So just change the numerator there to a 2A, divide by 1 minus R. And then we are done with the second half. Is this okay so far?
Yeah.
Let's summarize whatever we have at the new page. I need more space. Okay, here, paste. And there. Paste. Okay, what do we have? We know that this expression on the left-hand side must be less than 4/5 of whatever S infinity, sum to infinity, less than. Is it clear?
Yeah.
Okay, very good. Then now we can move on and try to solve this expression. What did they actually ask for? What did they ask for? They asked for largest value of n for which this guy is less than. So find largest n. Okay, let's take a look. How do we solve this? I know this straight away. 2A here. It's like 2A multiple. You can always rewrite it as 2A times that fraction. And the other guy, you can also factor out the 2A. So you're left with just a 1 there, then you times 2A. What happens when you got 2A on both sides? You can cancel off. Then you're just left with the remaining fraction, whatever it is. Anything else to cancel? How about 1 minus R, 1 minus R? Can we do that? Cancel?
Cannot.
I cannot.
What is the denominator?
No, you can. You can cancel away in this case. The only time that you cannot is when you are introducing a division to the equation or inequality. Here, how do you get rid of divide? Opposite of divide is?
Times.
So you're actually, in order to get rid of it, when I say cancel, what I mean is I am multiplying by the opposite of the divide. So I'm actually multiplying by 1 minus R on both sides. Is that legit? Is that allowed? Yes, multiplication will always be allowed. Doesn't matter whether it's 0 or not. You just need to make sure that the direction of the inequality stays the same. So does it stay the same?
Yeah.
Let me just introduce one intermediate step first. Then times does it stay the same? That requires the 1 minus r to be what in order to stay the same?
Like
See,
positive.
more than 0, which means that your r has to be equivalently less than 1. Is that true?
Yeah,
What is r again?
it's the ratio
Which is?
that is more than 0.
Which is? Which is?
Oh, it's 3/4.
Yes, okay. Circle so many times. Like, okay, yes, it's 3/4. Okay, therefore, r, we literally found it to be 3/4. It is less than 1. So is this obeyed? 1 minus r is more than 0? Yes, it is obeyed. Okay, therefore, do we need to flip the direction of the inequality?
No.
No flipping. No need to flip because 1 minus r is more than 0. Okay, good. So therefore, we managed to safely cancel away the 1 minus r, and we are left with, let me just copy down, then erase times 1. I'll just erase it. I think it's clear enough, right? 4/5 times 1, just 4/5. Okay, very good. So now we have this expression, 1 minus r power n less than 4/5. Actually, we could have just directly replaced the r with 4/5. But okay, I didn't think of that. So remove the bracket. Now we just substitute in the r with 4/5. Then we're left with 1 minus 4/5 to the power of n less than 4/5. Let's try to solve this manually. How will we do that? Let me see. Let me just confirm first. Am I doing this correctly? Yeah, I'm doing it wrongly. R is not 4/5, it's 3/4. sorry. 3/4. Okay, so let's try to solve for negative 3/4 n, power n. You have to subtract 1 on both sides, so it's negative 1/5. Then times negative 1 on both sides, we get 3/4 power n more than positive 1/5 times negative 1. This one is subtract 1, this one is multiply by negative 1. Is that okay?
Yeah.
Good. So 4/5 minus 1, you can use calculator to get negative 1/5. Or you can ask a primary school student to do it for you. Okay, anyway, 3/4 power n more than 1/5. How would you solve this? You can use a GC already, but let's just try to be fancy and use logarithms. How will we solve this if we take logarithm on both sides? So I want you to think carefully. When we take logarithm on both sides, right? Just now I told you, when do you need to flip the direction of the arrow?
When it's negative.
No. When it's, I gave 2 examples, yes, negative and 1 over x. But the common pattern is that they are both what kind of functions?
Decreasing.
Decreasing function. So let me ask you, ln, let's say we take log base e, because I just like base e, it doesn't matter what base you choose. Is it increasing or decreasing function?
It's decreasing.
Huh? Hey, you go and draw a graph. Why you got ln x? Come on. Increasing or decreasing? As x increases, what happens to your y? This is the graph.
Increasing.
Yes, it's increasing. So it's not decreasing. So do you need to flip the direction?
No.
No need to flip the direction because ln is an increasing function. Because ln x is increasing function. Increasing function, leave the sign alone. The direction alone. If it is decreasing, you have to change. Okay, anyways, why do we take the logarithm?
But when you key the ln inside the
Ln x.
calculator, is negative though.
Negative, yes. Of course it will be negative. That makes sense. Like if it passes through 1, 0. No. When I say increasing function, I'm looking at the direction that the graph is going in. The graph, not the value.
But if I divide over, isn't it still a negative number?
Divide over, that's later. That's later. Correct. But we do it one step at a time. Logarithm, increasing function. So currently, do you agree it is more than?
Yeah.
Okay, then we move on. Yes. Carry on. Yes, divide. Wait. We get n multiplied by ln 3/4. I'll just use one color. Getting too confusing. N times ln 3/4 more than ln 1 over 5. Okay, just use logarithm rule. Bring down. It's exactly equal. I'm just substituting the left-hand side with this guy. Then after that, you solve for n. There is this value here, which yes, you told me is negative, correct? Because 3/4 is less than 1 and more than 0. So the direction of the arrow needs to be flipped around. So ln 1/5 is whatever number, you divide by that number ln 3/4, which is negative. When you divide by negative, what happens?
Must flip the direction.
Flip the direction of the arrow and less than. Okay, then you can key in the calculator that value. ln 1/5 over ln 3/4. I got approximately 5.5945. So n is less than, but we know that n is a what? N is referring to number of terms, right? Which must be what kind of number? Can it be decimals?
Positive. Integer.
Must be an integer. So in this case, less than 5.5 means the largest value of n must be. Answering back to the question, largest value of n must be?
Is 5.
Exactly, that's your answer. Okay?
Yeah.
Yeah, this is a standard question actually. Like getting inequality. Actually, at this very first, up to this step, you can just use a GC already. Draw these two graphs. Or you could also rewrite it as 1 minus 3/4 power n minus away 4/5 less than 0. So just key this inside your GC, check the point of intersection with the y-axis. I think it's a decreasing function. It will eventually intersect at 5.54. What was the answer? 5.5945. I think so. Or maybe it's more like this. I don't know how the graph looks. You can go and draw it yourself. Can?
Can.
The intersection with the x-axis, n-axis will be 5.5945. So you know that less than that, it will be less than 0 below the x-axis. Then the answer must be n equal to 5. Okay?
Yeah.
I think maybe this is faster rather than doing it manually. Okay, moving on. Next question. Okay. Let's see next one. What is this question? This is question. Oh, this is what question number? This is question number 4, is it?
Yeah.
Okay, what happened? Let's read the question first. The nth term Tn of a sequence is given by log of 2 times x power n minus 1. Assume that it is log base 10, where x is a positive constant. Now, show that the sequence is. Why do they have to mention that it's a positive? It's to make sure that the logarithm is defined. Because if you take the log of a negative number like -5, is it defined?
No.
Undefined. So we don't deal with the negative. That's why we force it to be a positive. Okay, let's just it's given by the question. I don't have to question it, but don't need to question the question. But you just need to understand why they told you positive. It won't work if it's not positive. Now show that the sequence is an arithmetic progression for all positive integers n. So let me see what you did. Log of 2 times x power n minus 1. You split up.
I got the question correct.
Oh, you got the question correct. Okay. Then I don't need to go through with it. Sorry.
I think so. Yeah.
Okay. Good. Then I move on. Which else did you? Oh, this one circle.
Like part A. I can.
Part A only.
Yeah.
Okay, let's take a look. Find the sum of all the integers between 1102 and 2011 inclusive, which are not divisible by 3. So in this case, divisible by 3 means what?
Like it's like not odd number, so it's even number.
No. Divisible by 3 means it's 3 times some integer k. Not just means it's something else. Something else. It can be even, can be odd. 6, Okay, wait. 2 times, let's say 10. Is it divisible by 3?
No.
It's not divisible by 3, but it's still even. Not divisible and even. How about let me think about odd number. 35? It's
no.
also not divisible by 3, but it's odd. So both cases are possible. I was actually thinking of the prime factorization of 2 times 5, and then this one I try to avoid 2, so I end up with 5 times 7. So both don't have the prime factor of 3. This one has an even factor, this one 2, this one doesn't have an even factor. Right? So it's not related to even or odd. No.
Oh.
All right. Okay, not related to even or odd. Here, what you should do is to think of the easier example, okay, which is to sum up all of the integers, right? You see the numbers which are not divisible by 3 and inside this range, can it be more than the number of numbers inside this range? Cannot be, right? It has to be less than numbers inside this. So let's just find a maximum value upper bound first. So in this case, question 5, oh, this is part B. Question 5. Okay, let's just deal with 5 part A first. So what we can do is to sum up all the terms. Sum of all integers from 1102 to 2011 inclusive. Inclusive means what? Inclusive means you include 1102, include 2011. So this is just a arithmetic series, right? So you have to use the formula. What is it? N over 2 times
of the 2a plus n minus 1d.
Yes, then now we fill in the blank. So what is the n number of terms? Always remember, let's say for example, 3, 4, 5, 6, 7. How many terms are there? Obviously 5, right?
Yeah.
But how do you get 5? Is it 7 minus 3?
No, you must plus 1.
Must plus 1, upper minus lower plus 1. So here you got upper, there is lower. So what's the answer for n? Must be
Like
upper minus
the 1102 plus
and then
1.
you plus 1. Very good. Okay, so let's just simplify straight away. Let's just do it outside. So n equals to this guy equals to, I need a calculator. 910. Do you get the same answer?
Yeah.
Can n is 910. Then you just fill in the blank. So 2a plus n minus 1b. Okay, you know what? I'll just leave the formula alone so you can have a reference. And I'll replace the n with 910 over 2 multiplied by 2a. What is a?
The
Actually,
1102.
Okay, can. And plus?
The 910 minus 1 times
All the integers. Integers, what's the difference between 1102, 1103, 1104, all the way to 2010, then 2011?
so it's 2.
Huh? Do you know what we're doing when we say sum of all integers? Means 1102 plus 1103. What's the difference? 1104. What's the difference? Hello.
I thought it's 2.
All the integers. 02 to 03. What's the difference? 1.
1.
Why would you say 2? What makes you think it's 2?
Because I thought we skip one number.
No. Here is sum of all. Sum of all. We don't look at the divisible by 3 first. I'm starting with the simpler case where we add up all of the integers. Get the upper bound first.
Oh.
Because the question is asking for the numbers within this range, such that they are not divisible by 3. And then you want to sum them up. Okay, like for example, maybe I give an example. 10, 11, 12, 13, 14, 15. This, let's say instead of 1102 and 201, I change it to 10 and 15. Then the question is, find the sum of all the integers within 10 to 15, which are not divisible by 3. So what are they? Not divisible by 3. Let's just take the ones that are divisible. Divisible by 3. Divisible by 3. Not. Okay? Yeah. So our goal is to find out 10 plus 11 plus 13 plus 14. But I'm telling you that this is less than the sum of all the numbers. And currently, we are still at the step 1 first. We find out this big number. Make sense or not? 10 plus 11 plus 13 plus 14 must be less than the sum of all the numbers.
Yeah.
Okay. But more importantly, maybe I should have started with a simpler example to give you some intuition. now that let's say we found this answer already, how can we get the answer for the sum of these green color numbers? Maybe blue color. This orange one is all of the numbers here. What can we do to get the sum of 10 plus 11 plus 13 plus 14? How about if we just take this orange number and we subtract away those that we don't want, the ticks. So in minus 12, minus 15. Does that work? Instead of less than, it's exactly equals to this guy, but minus away bracket 12 plus 15.
Yeah.
Can, right? And these are also known as the numbers which are divisible by 3. The complement, right? Like probability. Can? Okay. So then you can generalize this up. Doesn't have to be starting from 10 to 15. We can start from 1102 to 2011. Just find this big sum first. Then after that, we can subtract away those that are divisible by 3. Then we'll get our answer already. The sum of the numbers which are not divisible by 3. You take the total minus away the total by the complement, so you can get your answer. Similar to counting. Like permutation combination, remember the topic?
Yeah.
Complement. Do you want to find those that are not divisible by 3? You just take the total minus away those that are divisible by 3. Okay? Yeah. I didn't want to say that until later because I want you to focus on finding the total first. Okay, so let's just focus on this first 50%. Later, then you just find out the divisible by 3, you subtract, and then you're done. So let's just focus on this first 50%. All of them. So tell me again, what's the difference here? All of them. So plus 1, plus 1, plus 1. So the difference is?
1.
1. Very good. Okay. Then after that, you just replace it with a 1. Is that clear? We are focusing on the sum of all the integers first.
Oh, yeah. Okay.
Okay, now then you just fill in the blank. Actually, there's a smarter way to do this, which is to always remember, instead of 2a plus n minus 1d, think of it as a plus n minus 1 times d. Split the 2a up into a and a. And not just that, this last lump here, you can just call it L. L for what?
The last term.
The last term, right? In this case, once you remember it as a plus L, right? It's very easy. Who's A? 1102. Who's L?
The last one, the 2011.
2011. So this is exactly equivalent to 910 over 2 multiplied by 1102 plus 2011. Can you type in the calculator and for these two expressions that I just circled in green highlight and convince yourself that they are the same?
Yeah. Yeah, the same.
Yeah, the same. And what is the advantage of knowing A plus L? It's simpler, faster, and what do we not have to find? We avoided
the difference.
As well as?
And
as well as? Hey, we avoided 3 things.
Oh.
And we just literally copy and paste 2011. A lot faster, right? You didn't have to find the number of, actually no choice to, the number of terms, no choice, I have to find it. But we avoided having to figure out what is D, right? The plus 1 and the first term. So I guess it's a little bit faster. Yeah, not much faster. Anyways, get the final answer, which is 1416415, right? Do you get this answer?
Yeah.
Can 1 million, whatever. Okay, so now that we know the total, just like the previous analogy, you got the total. What do we need to subtract away now? The sum of all the numbers which are complete the sentence.
Oh, divisible by 3.
Yes. The sum of all the numbers which are divisible by 3. Okay, so now our goal is to find sum of all the numbers which are divisible by 3. How do we do that? all the numbers which are divisible by 3 actually just means that you need to find your first integer that is divisible by 3 within this interval, and then the common difference is 3, right? You see, how did I identify that? How did I know that the divisible numbers are 12 and 15? What I did is I scanned through the numbers from 10 to 11, and then finally I hit the first number that is divisible by 3. Then after that, the next number must also be divisible by 3 by adding on a copy of 3, right? And the next one also divisible by 3, 18, divisible by 3, and 21, and 24. Does that make sense?
Yeah.
Okay, so how can you identify who's the first number here that is divisible by 3? Just take 1102 divided by 3 first. Is it divisible by 3? No,
no.
that's the remainder of how much? Shift SD and you'll get your answer. 367 1/3, right? Oh, sorry, are you using scientific calculator or GC now?
The scientific calculator.
Okay, then what's your answer? 1102 divided by 3 is?
The 1/3 is the
367
remainder.
1/3. So 1/3 is the remainder. In other words, remainder 1 whole. So there's an extra 1. That means that we owe how much in order? We have to go for the next number. How about 1103? How about 1104? You try 1103 divided by 3.
Cannot.
1104.
Can.
Okay, so we identified our first integer that is divisible by 3. 1104 is our first multiple of 3. Means it's divisible by 3. Okay, then we have to keep on adding plus 3, plus 3, plus 3 to get all of the integers which are divisible by 3. Then in this case, how many terms are there?
Don't
know, right? So we have to think a smart way to do this is to think plus 3 plus 3 plus 3 plus 3, right? How many terms are there? That's the most important part. We have to be less than or equal to 2011. Then let's think about it. 2011, is it divisible by 3?
No.
Maybe it's better if I just list down the numbers. 1102, 2011. Yeah, no space again. Wait a minute, give me a second. Okay, and finally done copying. Okay, so what we identify is that this is our first multiple of 3. Agree?
Yeah.
Then let me ask you, is 2011 divisible by 3?
No.
So is 20, how about 2010? Let's check.
No.
Huh? You try again? 2010 divided by 3?
Can.
Can 670? Yes, so this is actually our last multiple of 3. Agree?
Yeah.
Then, of course, maybe I'll just fit in one more just so you can see it clearly. 2007 will also be divisible by 3. Our second last. Can you see that?
Yeah.
Okay, then plus 3. Okay, maybe I just show one more number that's a second multiple of 3. So basically, this is the second multiple of 3. Is that okay?
Yeah.
Then now our goal is to figure out the sum of all these numbers. 1104 plus 1107 plus plus 2007 plus 2010. Let's just write it down. Sum of all multiples of 3 the numbers which are divisible by 3 is also called the multiples of 3. Means your 3 times some integer value, 3k of the format 3k. From 1102 to 2011. You realize that it's really just 1104 plus 1107 plus dot 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 plus 2007 plus 2010. Is that okay?
Yeah.
Then just add them together. So how many terms? Wait. First, pause. What kind of series is this? Geometric? Geometric needs ratio. Times? No, it's a common difference, so it's arithmetic series. So what's the formula again?
Is n over 2, then a plus
Smarter way,
L.
smarter way. A plus L, yes, correct. So how many terms? N. Let me ask you a question here. Let's say I start with 3, 13, 23, 33. How many terms? 4. How do you get 4?
I count like that.
Count literally, correct. But then how do you get a formula for it? If it was just 3, 4, 5, 6, it's very easy, right? I told you upper minus lower, then plus 1, right?
Yeah.
What's a smarter way to do it here? Well, maybe we can borrow the same idea. Upper minus lower, then plus 1. Is that correct?
No.
Not correct. A bit too big, right? So what's the problem here? 33 minus 3 is referring to the distance here, right?
Yeah.
Then what's the distance in between?
10.
10, right? The common difference, 10. So what do you think we want to do with this 30?
Divide by 10.
Divide by 10, then you get 3 and then plus 1. Does this give you 4?
Yeah.
Correct, right? So now can you link the same idea to the 2010 and 1104? What's n?
The 2010 minus 1104 divide by 3
Yes.
plus 1.
Very good, exactly. Let's calculate that. Upper minus lower, then you divide by the common difference plus 1. Okay, 303. Good. So now you get 303 divided by 2, multiply by first term. You tell me what's the first term? A?
1104.
And plus?
2010.
Very good. Okay, just key in the calculator now. I think I got 47. Did you get that?
Yeah.
Oops, and box. I'm trying to make it look nice. Okay, there's something like that. Okay, good. So now that we have obtained our multiples of 3, and also we got our previous total to be 1416415, what can we do to find the sum now? Big minus small, right?
Yeah.
So basically 1416415 minus away 471771. Then we will get our answer. Answer equals to this guy. I'll leave it to you to figure out. Okay.
Yeah.
Can? Okay, good. Moving on, next one. Next. Part B, okay, right?
Yeah, can.
Okay, can. Question 6 now. Anything wrong? If it's correct, I don't check already.
No.
No, Okay, next. Question 7. Money question. Let's take a look. So, so these two also not written down. Okay. Actually, just to save time, I think I should just look at the solution straight away. But before that, let's read the question first. So we got this insurance plan. They offer two kind of plans, plan A, plan B. Fixed interest of $100 for plan A. Fixed interest of $100 is added to the account at the end of each year if at least $1,500 was invested at the beginning of each year. So you have to top up 1,500, top up 1,500, top up 1,500 many times at the beginning of each year, each new year. Okay, then this one fixed interest. Plan B, interest is added to the account at the end of each year as well, but this time it's not a fixed amount, but rather it's a fixed rate of 3% of the total invested amount at the beginning of each year. So there's a cumulative amount every year. If you decide to add more money each year, then the total invested amount at the beginning of each year, this value would increase if you decide to deposit more money inside. But anyways, it will definitely increase because it grows by 3%. So if, for example, you put in $100, then at the end of the year, you just add on the 3%, so 0.03 times of 100, and you end up with 103. Then after that, you add on $3, so you have to plus 0.03 times of the current cumulative total, which is 103, assuming you don't add any extra money into the plan. And then you get some number. But actually, I shouldn't simplify it, right? I should just keep it as 100 plus 0.03 times 100. Then plus 0.03 times 103. But 103 is actually nothing but just the previous amount of 100 plus 0.03 times 100. Then you can distribute. So you end up with 100 plus 0.03 times 100 plus 0.03 times 100 plus 0.03 squared times 100. Is that okay?
Yeah.
Can yeah, then so on and so forth. You start to see the pattern already as a geometric series, right? Power 1, power 2. Okay. Moving on. That's just what you should notice while you're reading the question now. Haven't answered the question yet. Now, should possibly a client at any point in time decide to draw part or all of his investor amount, he will have to close his account. Okay, so he will lose he has to, I think whatever he accumulated, the interest will still be given to him, but he has to close the account. Just assume that they don't usually close the account, I guess. Mr. Wei is a client who invests $2,000 under Plan A in the first year. Subsequently, his investment at the beginning of each year is $400 more than the previous years. Show that at the end of n years, he accumulates a total amount of this expression. Okay, so what does that mean? It means that he started off with at least 1,500, the $2,000, right?
Yeah.
Then every year his investment will be $400 more. So next year he'll add in 2,400. Next year he'll add in 2,800. In general, up to the nth year, we'll figure out what the expression is. 2,000 plus 400 times how many? N minus 1. We'll figure it out later. This is 1, this is 2, this is 3. At the end of n years, then we have to calculate the total amount. So let's see your working. Start off with 2,000, good. End off with add on $100. Is it 100? Yes, fixed interest of $100. Then you take this amount, don't simplify, very good. You add on a new deposit of 2,400. Then what happens? You just add on another 100 here. So you start to see a pattern already. When it's 2 here, you have 2 copies of $100. By the way, this is also an advice that you can use in chemistry. When you put down the units at the top of the table already, you no longer need to put units here. In fact, it's wrong to put the units here.
Oh, yeah. Okay.
Because it will be read as dollars, 2,000. So it's like dollar square. What's dollar square? I don't understand.
Oh,
Doesn't make sense.
okay.
Right? It's like meter per second, you put down at the top, X, and you put 30 meter per second. It means 30 meter per second, meter per second. Doesn't make sense. Meter square over second square doesn't make sense. You shouldn't put the units anymore. Or the other way is you put X and you never put units, then you have to put units all the way inside the table. So you know one way is smarter than the other. Don't put units in all of the entries. Only put the unit one time in the table. Do not put units. It's wrong to put the units if you already have units in the top of the table. You should follow this same advice is used in the SPA exam, paper 3 for chemistry. Please don't put the units. I'm going to remove them all. Okay, can. After that, let's focus on the numbers. So 2,000 plus 2,400, you start to notice a pattern already. It's the first 2 terms of an arithmetic series with a common difference of 400, right?
Yeah.
Then you go on to number 3. By then, it should be obvious. If you take this over, copy and paste, 2,000, 2,400, 100, 100, you add on a new amount, 2,400. Then you start to see, oh, wait a minute, you can arrange these as one lump. That's one okay, sorry. You take this amount, then you add on the $100 extra. Let me see if you copy correctly. 2,000, 100, 100, 100. Correct. And then 2,400, 2,400. Okay. Yes, correct. Oh, you decide to lump the 2,400 together as one group. Okay, can also. Yes, then there will be n minus 1 copies of 2,400. Fine. Actually, wait a minute. I just realized you made a mistake. It should be 2,800, not 400. Right? He's very rich. He's very rich. He keeps increasing the amount he deposits every year. $400 more than the previous. Do you understand what this means? Every year he earns more and more money. So the amount that he can deposit inside the bank becomes even more. This time it's not 2,400 anymore. It's 2,800. That's a mistake. Do you see the correction? Do you understand the correction? Then the next year will be plus 3,200. Then the next year will be plus 3,600. So on and so forth. Is it clear? Yes or no? No, I cannot move on.
Yeah, can.
Clear or not?
Yeah.
So this just now you added 2,400. Now it's 2,800. Okay. So here should be, sorry, the extra copy here should be 2,800. Right? Okay. So I think it's easier if you just go to the solution. Give me a second. Here. Okay. It's not this one. Questions. I need the solution. Where is it? Solutions here. Yeah, here. Okay, they wrote it very neatly already. You start with 2,000, then you get 2,000 plus 100. Then the next year he deposit extra 400, so plus 2,400. Then he earns fixed interest plus 100. Then the next year you just copy and paste this expression, but now it becomes plus 2,800 instead of 2,400 again. And then after that you gain an extra plus 100 interest. And then by then you should realize there's a pattern, which is the 2,000, 2,400, 2,800 is an arithmetic series. This guy is just a constant, but multiply however many times. This is just arithmetic series where the first term is A equals to 2,000. The common difference is 400. And the n in this case is 3, because there are three of these terms. And just so happens it's the same as the n value here. Or maybe you can say n is just n. N is just n. Okay, you don't need to modify the n to be n minus 1 or anything. And then arithmetic series. This one is scratch word. It's not exactly equal. This is just like working, okay, to get the values you need to fill in into the formula. Then after that, you plus 100. How many times? 3 times. But that's just n. Maybe I should just put n equal to 3 and then just leave it as that. Is that okay?
Yeah, can.
You can start to generalize. Eventually, up to n term, you realize that it's 2,000 plus n minus 1 times 400. Is this part clear to you? Can you see the pattern?
Yeah, can.
Yeah. Can, because I'll just show one example. 2,800 is the same as 2,000 plus 3 minus 1, which is 2, times of 400. Okay? Because plus 400 2 times. At year 3, he have to add on 400 2 times, which is 3 minus 1 times. Okay? And then finally, you add on an extra 100. So this entire expression, you just convert it to a geometric series. Sorry. I use arithmetic series to simplify it. So the first half, you got 2,000 all the way to 2,000 plus 2,400 plus 2,800 all the way until 2,000 plus n minus 1 times 400. And then you add on 100n times, so 100n. Up to this step, is it okay?
Yeah, can.
Then it's an arithmetic series, right? So you just take the number of terms, in this case, n divided by 2 plus 2a plus n minus 1 times d, and then plus 100n. Simplify and expand, you will eventually get to the answer. Is that okay? It's just algebra, just multiply n over 2 in. But take note that this is one term in yellow. This is a second term in green. This guy, n over 2, you distribute into yellow, distribute into green. Can?
Yeah, can.
Can, I move on? Part 2?
Can.
Let's see your answer. Was your part 2 okay? Empty.
Yeah, I cannot simplify that one already. I think because it was
All
really
right,
wrong.
because it's error carry forward. Okay,
Yeah.
can. Let's just look at the question. So Mr. Wei, he intends to stay with AI until his total amount in part one reaches $100,000. So what is the least number of years he needs to keep his account open for? So basically, you can still do part two. This one, it will be very wasted during A levels if you decide to skip the question. Basically, they're asking you in part one, they're hinting to you just use the answer that was given in part one. Did you see that? Very important. This one exam technique. You don't just, I cannot solve part one, I give up. No. Use the answer that was given. That's why in part one is a show question. It's a bit difficult. But even if you cannot show it, use the answer so you can get some partial marks in the part two. I mean, no. You can get the full marks for part two by just using the expression here. Is it clear?
Yeah, can.
So all you need to do actually is just equate this to 100,000 and solve for n. 3 marks at this one.
Oh.
Yeah. Okay, just equate to 100,000 and then just solve for n. Oh, sorry, not equate. I mean, technically should be more than equals, but I think the simpler way is to just equate to 100,000 and then you get an n value. Let's look at the solution. So here they made it more precise. They say it should be more than equal, but for practical purposes, I think also easier for you if you just put a equal sign and then eventually you'll get a quadratic equation. You get n equals negative 27.6 or n equals 18.1. Negative is obviously irrelevant, so you can just ignore it. This guy n equals 18.1. So you must think logically lah. Would you want to keep for round down or round up in order to hit 100 at least $100,000? Should your final answer be n equals 18 or n equals 19? To hit a minimum of 100,000. Hello? Mic test, I cannot hear you.
Yeah.
I can hear you now. Yes. Do you understand what's going on? Take the answer from part one, equate to 100,000, solve for n.
Yeah,
You get a quadratic equation. Then you get these two answers, right? Then my question now is, this one obviously reject. You get 18.1. The question is, your final answer, n is referring to number of years you put in. You cannot cancel the plan halfway, so you must complete the year. In other words, n must be a what kind of number?
Integer.
0.7 years, 0.8, no, cannot decimal. So must be integer, whole numbers. So there's only two options now. You either round down or round up, 18 or 19. Which one is correct?
I want the 18.
18? Well, 18, you're not gonna hit 100,000. You're only gonna reach 99,000 something.
Oh.
Correct or not? You just take in. How do you check? If n equals to 18, you just check the value 2,100, and that's the amount under plan 1. Plan A. You just sub in n with 18. Then you type in the calculator, how much money will you earn after 18 years? If you ever do financial planning, I will be very scared of you. If you become a financial planner, I will be very scared.
I can use the GC table.
Sorry, what?
Can use like the GC, like can plot the table.
Table? No. Yes, actually, yes, you can. Yes, but yes, that's essentially what I'm doing. I'm just doing it manually. Yes, you can plot in the n value 1, 2, 3, 4, and then you key in the entire expression n squared plus 9.5 n minus 500. But basically, what I'm trying to tell you is that this value here is actually $99,000, which does not hit $100,000, which you can also intuitively understand that by looking at 18.1. You see, what does the 0.1 here refer to? It's not just for fun. It means that if the number of years you can put in is actually can be prorated, such that you can scale it to the amount of fractional amount of years that you put into the bank account, it means that in order to hit $100,000, you need to put in for 18 years and 0.1 of a year in order for you to hit that 100,000. If you don't have this 0.1, you're gonna be less than 100,000. So you cannot round down. You need to round up. You will exceed $100,000. That's why they mention in the question at least 100,000. At least, right? Did he not say that? He said reaches. Okay, sorry. I guess this means at least.
Oh, okay.
You cannot be exact. It's impossible. It's impossible. The only thing that's exact is the exact number of years. 1 year, 2 years, 3 years. Okay? Can. Yeah, okay, moving on to part 3. Miss Goon, this one smarter person, decides to take up plan B to accumulate $60,000 by the end of the 11th year. Given that she puts the same amount into her AI account at the beginning of each year, what is the minimum sum of money correct to the nearest dollar she will need to add to her account each year? How? You have to draw a table again? So how would you do it? Start, end in terms of dollars. I'm not even gonna put the units. I have no space. I can't squeeze this in here. See. I need the plan. I don't remember the plan. How many percent? Plan B. Let's see. Okay, so you have interest that's added to the account at the end of each year. I'm looking at plan B. At the end of each year, at a fixed rate of 3% of the total invested amount at the beginning of each year. So start, end. Yeah. You have N. 1. Starting amount, how much does she have to put? Since we don't know the amount, right, let's just let X dollars be that amount. So we focus on the value only, just X, don't care about the dollar sign. So starting amount, she put in X. Does she immediately gain interest? No, right? So we go on to the next one. After the end of 1 year, how much does she gain? X plus
0.03.
X. Here I will try to simplify it as 1.03x. I don't know if it's useful or not. Let's just use 1.03x. Then the next year, what happens to the 1.03x at the start? Does it stay as the same amount? Meaning she doesn't deposit money? Cannot be. She has to deposit money. She says at the beginning of each year, she puts the same amount. So that means you have to plus how much?
Plus X.
Plus X. In this case, that's all. You don't need to modify the X you don't need to modify the X like the previous guy. He always add $400. Here just plus a fixed amount X. So we take that amount. Actually, you know what? Let's just simplify a bit. Okay, I know I'm going against my advice, but hear me out. It works. You factor out the X. Then you take this amount. What do you do? Sorry. What do you do? You gain interest, right? How much? 0.033% of that amount, which is X times 1 plus 1.03. Is that okay?
Yeah.
Actually, I don't need that pair of brackets. Can. Now, actually, what you realize is that this is actually just, if you call this P, this will be plus 0.03 times of P, which is actually just 1 plus 0.03, which is 1.03P. Is that clear?
Yeah. So
we can simplify this as 1.03 times of P. In this case, the P is just the X multiplied by 1 plus 0.03. Is that okay?
Yeah.
Then you can multiply the 1.03 in, so it becomes X times the 1.03 goes into the 1 and 1.03. So 1.03 and 1.03 squared. Is that okay?
Yeah.
Can. So we move on. Now we have, did I get anything wrong? There's no there's no constant term in the front. That's a bit funny, but it's okay. It's correct. Then we move on to next year. I think you can see a pattern already. What kind of series is this? Before I move on.
Geometric series.
Who's the A first term?
1.03.
What's the common ratio?
1.03.
Very good. And how many terms are there here? Here, just currently.
2.
2 terms. How do you link it to the n value? It's the
Same.
same. Do you need to n minus 1, n plus 1?
Don't need.
Don't need. Okay, very good. So let's just go on to the third term. Same story again. Copy and paste that amount, that expression, and then you add on a fixed amount x. Then this amount we can simplify it, so it becomes 1 plus 1.03 plus 1.03 square. And you take that amount at the start of the year, you gain interest at the end of the year, so times 1.03. Is that clear to you? 1 times 1.03?
Yeah.
I'm skipping a step. Typically, it's the original amount, the principal, plus the interest, 3% of that original amount. But combined together, it's just 1 times of that original amount plus 0.03 times of that original amount. So to all together becomes 1.03 copies of that original amount. That's why I times 1.03. Okay? So x multiply in and you end up with 1.03 plus 1.03 square plus 1.03 cube. Clear so far?
Yeah.
Then our focus is on what? On the amount that she will. Let's read the question. What is the minimum sum of money correct to the nearest dollar she will need to add to her account each year, such that she can accumulate $60,000 by the end of the 11th year? So end of the 11th year means we are focusing on n, and we're focusing on row n equals to 11, right? Don't even really need the generic nth term. Can you just immediately tell me what would the 11th expression, the n equal to 11th term will be?
For the start.
Don't need start. Remember how I told you that in table questions, there are 2 ways to it. And in both of these ways, sometimes the start may be blank. You may not need to put in the start if you are fast enough. And I recommend you to be faster a bit. You don't need to fill in this one. You get what I'm saying? Because the question only asks for the n, the purple one. So we do that, okay? We do that.
Okay.
Jump straight to the faster a bit, taking a bit too long. Yeah, so let's just skip this and just jump to the conclusion straight away. I think you can tell quite easily what will be the conclusion, right? X multiply by
1.03 plus 1.03
square plus dot, and then plus 1.03 power
11.
Exactly, that's all, right? You don't even need the start. I mean, if you really wanted to, you need to transfer the term from the previous one. Then do you actually know what is that term? You have to think a bit, right? Which means that you actually end up finding out the expression, but with power 10. So there's no point to doing this. No need to find this one. Okay, just get the final answer. Good. So this question is kind in the sense that you don't need to get the generic nth term. So we need this expression at the end of 11th year to be what? To hit at least to what is it again? What did she say? Ayo, what did I do? Where am I? The question is here. To accumulate $60,000, right? But usually, can you be exactly equal? Cannot, right? So that's why we will say more than or equals to $60,000. It's quite likely that it won't be exactly equal. It will be probably more than. Okay? But just to make your life easier with the algebra, I'm just going to put this as equal. Then after that, we can solve for x. Now we can key this into the key this value into the calculator directly without using geometric series formula. Just manually key in all 11 terms. But I strongly don't recommend that. Your calculator may crash because the power 11 is a bit difficult for the calculator to compute, especially when there are like 10 of them, 11 of them. The calculator will slow down a lot. So yeah, don't do that. Instead, we use the geometric series formula, and then finally we get, can you recall the formula? Recite the formula for me, geometric series.
The
A times
1 minus Rn over 1 minus R.
Rn, or you say Rn, so R times n. Is it R times n?
No.
Or is it R subscript n? R subscript.
Subscript. And
subscript is at the bottom. So is this correct?
No,
don't need to raise to any power. Just a subscript. So its name is n. The nth R, no, it's power n, right?
Yeah.
Divide by?
The 1 minus r.
Very good. What is A? Give me the English name.
The first term.
What is R?
The ratio.
What ratio?
The common ratio.
Common ratio. N is?
The number of terms.
Okay, very good. Then R again is the ratio, common ratio. So you must remember first term, common ratio, number of terms. Is it always literally A, literally R, and literally N?
No.
No, you must contextualize. So contextualize now. What's a A?
The 1.03.
Open bracket.
The 1 minus 1.03 to the power of 11.
Because it starts with power 1. Okay, can?
Then
1, 2.
over 1 minus 1.03.
Very good. Let me ask you a question. If I have like 1 plus 1.04, totally unrelated question, plus 1.04 square plus 1.04 cube, can you try to give me the series this time?
The 1.04 bracket 1 minus
Wrong already.
1.
It's the first term. Yes, it's 1, right? The trick here is if you're confused, I'm going to draw arrow, then times 1.04. Arrow times 1.04. Arrow times 1.04. Okay, try again. So 1 times, open bracket.
1 times 1 minus 1.04.
Think carefully. What's power? Power 1 again. And what's n in the English phrase?
Is 4.
Of terms. Yes, it's 4. Don't just blindly see 3 and put 3. Clear or not? 1, 2, 3, 4. Count the number of terms. Then?
Over 1 minus 1.04.
Well done. Very good. Okay. Main takeaway I want to bring up here is the first term and the nth term may be different. Contextualize. Don't blindly memorize. Okay. Yeah. Can memorize the correct thing. I said first term. So I typically memorize my geometric series as in English. First, I actually both, but I memorize both. First term multiplied by 1 minus the common ratio raised to the power of the number of terms, all divided by 1 minus the common ratio. Why do I force myself to memorize the English phrase? Because it reminds me that, I cannot just blindly see 1.04 when put 1.04. I cannot just blindly see power 3 and I put power 3. I need to count the number of terms. 1, 2, 3, 4, not 3. First term, just look number 1 there. And this only applies to what kind of series?
Geometric series.
Geometric series. So does it mean I see plus, then I immediately think I use geometric series? Is that the reason?
No.
No, it's because of the what pattern are we?
Ratio.
The common ratio. Draw an arrow, there's a times, and the ratio is the same for all of them. Okay? Understand?
Yeah.
The requirements for you to use the formula, don't just blindly use it. Okay, moving on. So this equals to 60,000 and then just use a GC to solve it. Blah, blah, blah. You will be able to obtain X to be 4548.20. So this is with equality sign. But Miss Guna, you want to think for her benefit. She wants to earn, is it better for her to earn more than 60,000 or less than 60,000? Beneficial for her to earn more money. More money is better. So would you want this X to be bigger or less in order to hit that 60,000?
Bigger.
Bigger. So that means the least number of months, least amount of money she has to put in must be 4549, assuming that it is a whole number. Because, wait, did they mention that? Correct to the nearest dollar. Okay. So, yeah, you cannot round down. If you round down, then you will hit like $59,000. You won't hit the 60,000. Really serious. Cannot go below. Okay. So round up. Round up, despite the fact that 2 typically you think 0 to 4 round down, then 5 to 9 round up, right? But here, because of it's a money question, you must think of the context. Round up in order to hit the minimum amount of 60,000. At least. Is that clear?
Yeah.
Because money. Okay. Because money. It's not just money actually. No. Because you want to hit minimum at least. Don't say minimum, at least 60,000. The moment you round down, you will hit 59,900 something dollars. You can go work it out yourself. You won't hit that 60,000. Okay. Can finance question, okay?
Can.
Start. And then don't blah blah. Must make sure you add the correct amount. Over here is not 2,400, it's 2,800. Read the question correctly. Yeah. Okay, that's question 7 done. Moving on. Next one. Oh, 12:30 already. Okay, question. What's the other two question? Question 8 and question 9 is okay. I'll just go straight to the answer. Yeah. So let's take a look at the question. Not that easy. Question 8. Jerry, he starts a game card collection by buying A cards. Subsequently, the number of cards he buys each week is D more, so A plus D. And then the next week is A plus 2D, A plus 3D, A plus 4D, so on, so forth. Then he bought the previous week. Okay, he collects cards for a total period of 3N weeks. So the number of terms is how many? How many terms are there?
A.
How many terms are there? In other words, how many weeks are there?
The 3N.
3N number of weeks. So in this case, it's like, if I can just copy the question over somewhere. Let me see. It's like this. A plus D, A plus 2D, A plus. So this is the first day, the second day, the third day, then so on and so forth until, let's say, we hit the N minus 2th day. You have to add how much? See, N minus 3, right? D.
Yeah.
Makes sense or not? 2 becomes 1D, 3 becomes 2D, minus 1. N minus 2 becomes N minus 3. And if it's the N minus 1th day, what's the expression? A plus N minus 2D. Then if it's the nth day, A plus
N minus 1.
N minus 1D. Then after that, so on and so forth until you hit, let's say, 2nth day. What would it be? A plus? Sorry, it's not days, weeks.
2n minus
1D.
1.
Correct. Yes, 2n minus 1. Always take the number on top, then you minus 1. Take the number on top, minus 1. You get the expression. N minus 1 minus 1, N minus 2. Take the number on top N, minus 1, you get N minus 1. Take the number on top 2N, minus 1, you get 2N minus 1. Clear so far?
Yeah.
I need to repeat this part, minus 1. Then
No.
now, immediately, if I extend it to 3N, you should know the answer, right? Dot. The 3nth day, 3nth week, sorry, keep saying days. Wow, if you buy every day, that's going to be a very big problem. 3nth week, how many cards? A plus?
3n minus 1.
Close bracket.
D.
D. Very good. Okay. Then this is the number of cards each week. We listed them down one by one. Here, let's read the question. If P is the number of cards collected in the first N weeks, in other words, this guy is the sum is equals to P. And Q is the number of cards collected in the last N weeks. Last N weeks means what? Does it include 2N and 3N? The 2N week and the 3N week? All the way to 3N week? Or do you start from the 2N plus 1 week?
3N.
Last N. No. I'm asking, okay, I add in one more term on the 2N plus 1th day. Sorry, week. 2N plus 1 week. How many cards?
The A plus 2N times D.
Very good. 2N plus 1 minus 1 is 2N times D. Okay, so my question is last N week, you see, maybe I should write this down like this. This guy sum is equals to P. Then last n. This is for first n. First n weeks. How about the last n weeks? Does it include, is it 2n plus 1 to the 3n? Or is it 2n to 3n? Maybe if I replace n with if we end with like, let's say 3, that means what? 2n must be 6, 3n must be, wow, why did I pick such a big number? Can I just pick 2? 2 times 2 is 4, and 3 times 4 is 12. So in other words, we got 1, 2, let's list it down, let's just do it. 7, 8, 9, 10, 11, 12. First n weeks is referring to the first 2 weeks, right? So it means these first 2. How about the last n weeks?
So it's 11 and 12.
Actually, just 11 and 12. It's not 2n plus 1. Sorry. Did I interpret wrongly? I think I did. You don't include 2n plus 1. Should be. I need more space. Wait a minute. Last n. So in this case, actually it's 2. Over here, the n, it may not be 2, right? So is it 3n minus 1? Only?
No.
No. This one is the n. Sorry, so this guy is the 3n. This guy is, although in this case it is 3n minus 1 purely coincidentally because I picked n equal to 2 because I don't want to draw so many numbers. It's in general, this is not the 3n. This is actually the 3n minus 2n plus 1. Yeah, I was right the first time. Oh my goodness. Makes sense or not? 3n minus 2n plus 1 is equal to what? It's equals to n plus 1, which is 2 plus 1. It's 3. Oh, sorry. Am I wrong? Oh, right. I think I'm wrong. Hey, sorry. Let me think a bit. Last n. Sorry, my mental sums failed. What is 3 times n? N is 2, so 3 times n is 6. N equal to 2, 3n is equal to 3n equals to what?
What?
Sorry. My example, I calculated wrongly. I am so sorry. N is equals to 2. So 3n is equals to what value?
6.
2 times 3 is 6. Not just 6 only. Not 12. Sorry. Okay, in that case, let me just use a different number. I'll just restart. I don't use 2, 4, 6. I use a bigger number, 3. So n equal to 3. 2 times of 3 must be 6. 3 times of 3 must be 9. So we end up with 1, 2, 3, 4, 5, 6, 7, 8, 9. Agree? Can
Yeah.
First n is referring to these first n. Last n is referring to these guys, right?
Yeah.
Now the idea and question is this 7 here, what's the index number in terms of n? Isn't it 2n plus 1? 2 times 3 plus 1?
Yeah.
Correct, right?
Yep.
So it's not 2n, right? It's not 2n. Then this guy is 3n. Make sense?
Yeah.
Okay, so the last n is actually starting from the 2n plus 1 term all the way to the 3n term. Is it clear?
Yeah.
Clear, Very good. So now we go back to the expression here. I was right the first time. Oh my goodness. So can I ask you again, when you want the last n terms, do you include 2n? Do you include 2n or do you exclude 2n? Here, did we include 2n, which is 6, or do you exclude the 6?
Exclude the 6.
Exclude the 6, which is the 2n. So here, in general, we exclude the 2n. So who is my last n? Can you draw a box? Can you draw a box? I box up the first end. Can you draw a box around the last end? Have you drawn it already?
This one.
Very good. Exactly. It's the last 2n plus, starting from 2n plus 1 term. So that's your last n. And the summation is equals to q. That's what they mean. Is it clear?
Yeah.
Can. So what else do they tell you? They tell you that show that q minus p equals to 2n squared plus d. How? Let's just figure out an expression for p first. P equals to what? A plus c plus a plus 2d plus a dot, 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 until a plus n minus 1. What kind of series is this? What kind of series? You only got two choices there. Arithmetic or geometric? Flip a coin.
Arithmetic.
Arithmetic series. Because there's a plus d constant difference. So what's the formula?
The n over 2, then the first term plus last term.
So think carefully. Can we blindly put n? No, we have to think carefully whether it is really n. In this case, yes, it is n. I already label index 1, 2, 3 all the way to n, so definitely n. So we can blindly copy in this case. Later on, please think a bit. How about the first term? Yes, I can see, right? Index 1, so of course it's a. Last term, instead of L, it will be now
A plus n minus 1 d.
A plus n minus 1d. Very good. So it's the standard formula. Standard formula 2a plus n minus 1 times d. So let's just simplify it down as n over 2 times 2a plus n minus 1 times d. This is the case where writing it as 2a would be okay. Let's just move on to q. What is q? What kind of series? What kind of series? Two choices. MCQ, arithmetic or geometric? Times or plus? Which one?
Arithmetic.
Arithmetic is plus d plus d plus c. So how many terms? The Q is referring to the what? Q is the number of cards in the last n weeks. So how many terms?
N.
Yeah, exactly. It's just n, right? Then you just use the formula. Well, I'll just copy it down first. N over 2 times a plus l. N is literally just n. Alternatively, you can also calculate it as 3n minus 2n plus 1, then add on a 1. Big minus away small. The common difference is 1, then you plus 1. It's just n. Is it not?
Yeah, it is.
It's n. So number of terms is just n. Okay. First term plus last term. Now fill in the blank. What's your first term? Is it just a? What's your last term? Is it just l?
No. It's the a plus 2n d and a plus 3n minus 1d.
Exactly. So just fill in the blank now. So you end up with a plus 2n bracket d times d. And the other guy is a plus 3n minus 1 times d. Okay, good. Clear?
Yeah.
Let's just simplify it, make it clean up a bit. So well done, very good. And then what else do you know? I can simplify a bit more. I realize there's an A and A, so it's 2A. I realize there's a D and D, so I can factor out a D multiplied by 2n plus 3n minus 1. Is that okay?
Yeah.
Simplify a bit more, 2n plus 3n is 5n. I'll just erase and write down 5n. 2n plus 3n is 5n minus 1. Okay? Can? Okay, very good. So now we have P and Q. What do we want? They tell us show that Q minus P equal to n squared times D. So let's just calculate all Q minus P. Q is this fella, copy and paste. Copy and paste. subtract away P. Okay, subtract away P is n over 2 multiplied by whatever. Is that okay?
Yeah.
Good. So what do we do next? Simplify.
Yeah.
So let's just multiply in n over 2 times 2a. I'm not even going to simplify this because I straight away see that there's a minus n over 2 times 2a, so they will cancel off straight away. Plus n over 2 times d times 5n minus 1. And minus n over 2 times positive, you get negative n over 2 times n minus 1 times d. Anything to factorize? Yes. N over 2 times d. N over 2 times d. Factor out that n over 2 times d. What are you left with? 5n minus 1, subtract n minus 1. Is that clear?
Yeah.
Maybe I'll highlight it. Positive 5n minus 1. Negative n minus 1. So negative n minus 1 bracket. Clear? Good. Simplify. N over 2 times d. What's our n go again? 2n squared times d. So even though we got two variables here, n and d, it's perfectly fine. Continue simplifying. 5n minus 1 minus n minus 1. So 5n minus 1 minus n plus 1 after you open up the bracket. Is that clear?
Yeah.
Simplify a bit more, you get n over 2 times d multiplied by 5n minus n is 4n minus 1 plus 1. Minus n plus 1 becomes 0. Can?
Can.
Clear so far? And I hope you can see something can cancel away.
Yeah.
What?
The n and
The n can
4.
cancel. Okay, well, so simplify for me. What do you get?
The 2n squared d.
Yeah, the 4 and 2 cancel away. 1, 2. Then you get 2n squared d. Okay? Yes, shown. So long-winded. Okay, done. Clear?
Yeah.
Okay, moving on. So now I'm just going to go to the solution already for the other part B. So for part B, okay, you can go and look at how they did it. Okay, I need to read the question first. Part B, fund is established with a single deposit of $2,500 at the beginning of 2011 to provide an annual bursary of $150. So that means that there is this government agency who is collecting money. So they have a piggy bank. Okay, piggy bank. Okay, then inside got money. What happens? You deposit $2,500 inside. In 2,500 in. And then there's interest. There's interest. R% interest. You earn interest. But then it's a leakage. Okay, not leakage. I mean donation bursary to people. So $150 goes out of the piggy bank. Keep on depositing and then you leak. Deposit and leak. Like a water tank. Water go in, water go out. Like money is like water, I guess. I don't know. Anyways. Oh, sorry. This 2,500 is a single deposit because not enough money. So only times one, unfortunately. It's not every year you deposit increasing amount of money inside. There's only a one-time deposit of $2,500. Is that okay? This is my piggy bank. Inside got $2,500 and it will gain interest. However, the $150 is being removed each year, a fixed amount. Also, the interest is 3.5% per annum. So maybe I should write down 3.5% PA. Yeah. So this interest is only paid at the end of each year. However, the annual bursary, when is it released? When is it given out? I'm also not sure. Let's continue reading. If the first bursary is awarded at the end of 2011 after interest is earned, show that at the end of n years, the amount in dollars remaining in the fund is this expression. And when will be the last year that the bursary can be awarded? What this means is that this $2,500, after you minus 150, you gain interest and then you minus 150. Gain interest and then minus 150. Gain interest and then minus 150. There will be a net loss of money. Okay, there will be a net loss of money that follows this function here, this expression. Eventually, the piggy bank will run dry, no more money.
要吃了，他们 K GM 叫我们早吃，last minute 换我的 lunch hour，看我都不可以 rest。
Okay, hello. Can I continue?
Yeah, can.
Can All right. Can going on. So what we have now is to draw a table, start and end, and figure out the amount inside our piggy bank. Okay, so let me just copy down this piggy. Yeah. Oh no. Never mind. I'll just remove the pig. You get the idea, huh? So in 2,500 times one time, 3.5% per annum PA, and then leakage of $150. So we're gonna calculate. So amount the fund at the end of the year. So sometimes they're even more sophisticated. They'll just go straight to the end of the year. They don't even show you the start. Because the start is boring. Nothing happens, right? Because there's only a one-time deposit. There's no additional deposit made into the bank at the start of each year. Money is just deposited one time and then being leaked out at the end of the year. Okay, there's a rise in the interest and then a leakage because of the $150 bursary. Make sense?
Yeah.
Can So that's why there's only the end of the year. You don't need the start because there is nothing interesting happening at the start. So that's what we're gonna do. We're gonna start off with your 2,500. We earn a 3.5% interest. So what does it mean? 3.5% actually means 3.5 divided by 100, which is 0.035, right? So if you want to take the interest amount you earn is 0.035, you multiply by the principal 2,500, that will be your interest. Okay, this is your interest. But if you want the total amount, it will be the principal plus the interest. That's your total amount, which is your 2,500 plus your interest, which is your 2,500 plus the 0.035 times 2,500, which you can also rewrite it as 1 plus 0.035 times 2,500. So altogether, it becomes 1.035 times 2,500. Is that clear? It's like 135%, 103.5%, basically. To put it more simply, 103.5%. Okay, so that's why you got 1.035 times 2,500. Is this part clear?
Yeah.
But what happens? Every year you give out the bursary, so your piggy bank minus away $150. All right? That's the net amount. Is there new money being deposited into the piggy bank? The fund?
No.
No, there is no additional money put into the bank. If you just read the question, fund is established with a single deposit. So nobody want to donate money to the fund. Only a single deposit. Did they tell you every year we deposit extra money inside? No. So your piggy bank will eventually run dry. There's a fixed amount, 2,500, slowly leaked out. So nothing interesting happening at the start of the year, no extra deposits. That's why we take this original amount, then we just need to gain interest. So 1.035 times 1.035, and then you subtract away another copy of 150. Straight away, they multiply out already. So maybe if I just add in one extra line of working, no space. If I can just squeeze in over here, one extra line of working would be the following. 1.035 bracket 2500 minus 150. That's just the amount from the end of first year. You multiply by 1.035 to get the total amount after accounting for interest, but you give out the bursary, so minus 150. Okay? Is it clear?
Yeah.
Then you just have to times this into each of the term, and then you minus 150. So times in 1.035 becomes 1.035 squared times 2,500. And then 1.035 multiplied by 150, you get minus 1.035 times 150. And then subtract away 150. But wait, both got 150. So you can factor out the 150, or rather the negative 150. So it's a bit faster. And then you get 1.035 plus 1. Is it clear so far?
Yeah.
Okay, then they stop already. They never go for the third term. Can you try the third term? Without swinging the answer, can you figure out what's the third term? Just look at the final answer. Power 2 here, power 2. 3. I mean, end of second year here, so power 2. End of third year here, 3. So power what?
Power 3.
Very good. 2,500 remains, right? Then continue the rest.
150 bracket 1.035 square +1.
Oh no. You cannot see the pattern. That's wrong. That's wrong. If you say +1, it's wrong. Come on, we need a geometric series, right? So definitely your power must go one by one. Suddenly power 2 drop to power 0. Right, this is 1.035 power 0. Wow, bad handwriting. Sorry, let me try again. This is +1. So this is just 1.035 power 0. 2 suddenly drop to 0. Doesn't make sense. Okay, let's just work it out.
So it's the 1.0.
What's missing? Yes, it's missing 1.035 power 1. Right? Makes sense or not? Geometric series. If you cannot see it, let's just go through it. Okay. If you cannot see it immediately, then we just go through the procedure again. So row 3, we copy and paste the expression. Give me a while to copy this. Right, copy and paste done. Then you see the procedure. Maybe I write in pink color. Bracket times 1.035, then minus 150. The pink color is the new step. So we're going to do the new step. Bracket times 1.035 minus 150. Is it clear? Hello? Ken? Mic test, am I still connected?
Ken.
Okay, then after that, just multiply in. Go in now. So 1.0, first term, 1.035 multiply into 1.035 square, you get 1.035 power 3 times 2500. Subtract away 150. This time 1.035 times, okay, you understand how to multiply in, right? This expression.
Yeah.
It's that. Maybe if I write it. You sure? You understand?
Yeah.
This time times it in. Okay, don't touch the 150. Okay, you don't go and times the 150 with 1.035. The 1.035 is only multiplied into, it's a single factor, so you can only multiply it one time inside. Don't use it 2 times. I mean, the 1.035 only multiplies into the expression here with two terms in the bracket. Okay?
Yeah.
And then minus away 150. You realize. Same procedure as before. You got minus 150 here, minus 150 there. Minus 150 here, minus 150 there. What can we do?
Can factorize.
Factorize out the 150. No space, wait. Okay, I'm gonna shrink it down and then I'm going to zoom in. Looks okay, equals, and then 1.035 power 3 times 2500 minus 150 factor out, you are left with 1.035 square plus 1.035. And then if you factor out negative 150, that's a plus 1 here. Agree or not? Is it clear? Not clear? Silent.
Okay. I forgot to unmute. Yeah.
Yes. Okay. Good. Yeah. Okay. Okay. I should just immediately say I cannot hear you. If you no reply immediately. Okay, Ken. So this is the answer after you get power 2. So in general, the nth term will be what? The nth term you will just have to increase the change 3 to 3, then n change to n. Then power 2 here is just 3 minus 1. So that's why you have n minus 1. Is it clear for this n minus 1?
Yeah.
Can see the pattern. Must be able to see the general pattern. You cannot go all the way. You must be able to see the minus 1. Sometimes minus 1, sometimes plus 1. Usually, Then after that, just count down. So minus 1, so n minus 2, and then minus 1, all the way until power 1 and then power 0. This is 1.035 to the power of 0. So what is the geometric series? I'm sorry. What is the series here? Arithmetic or geometric series?
Geometry.
Geometric. Why? Because common ratio. I think it's easier if you think of it the other direction. Times 1.035 times 1.035 all the way. So geometric series tells you what? A times 1 minus r power n or divide by 1 minus r. Or in other words, can you say it in English? I'm going to write it down for you. Can you say it in English?
For which one?
The a times 1 minus r power n over 1 minus r. Instead of a, instead of r, instead of n, use the English phrase.
Oh, the first
Read this out loud. Multiply by open bracket. Say it. Okay, repeat. Start from the beginning.
First term bracket 1 minus common ratio to the power of the number of terms.
Close bracket.
Then divide by 1 minus the common ratio.
Very good. You speak it in English already. You better understand what you are speaking. First term, ratio, then number of terms. So tell me who's the first term when you read from right to left. The smallest guy. Is it 1.035 or is it 1?
1.
That's why A is 1. Then 1 minus the ratio 1.035, right?
Yeah.
Because of the ratio here. Then power number of terms. How come n not n minus 1? What's wrong? N is what again?
N is the number of terms.
Number of terms and it's n. Even though the power is n minus 1, here it happens to be n terms. Why? Because here you start with 1.035 power 0. This fella here is 1.035 power 0. This is power 1. So 0 go to 1, then go to 2, go to 3, go to n minus 2, go to n minus 1. How many terms? N terms. Make sense? Okay. Can I go think about it? So n terms, power n. Then divide by 1 minus the common ratio 1.035. Clear?
Yeah.
Then after that, you just simplify on your own already. I'm not going to go through. Clear?
Yep, can.
Can I? Okay, question 8 done. Then after that, what else did they ask you? They tell you that, okay, we got this expression shown already. Very good. When is the last year that the bursary can be awarded? You will only be able to award if the amount of money remaining is how much money? What's the award? What's the bursary amount? Annual bursary of?
150.
So if you not enough money, your wallet only got, let's say, $140. Do you dare to say, hey, never mind, I give you $150 and you owe that $10? Do you dare to say that?
No.
You don't have enough money, you still lend people money? Doesn't make sense, right? So that means that you want this amount to be at least how much?
More than 150.
Exactly. Okay. You can think of it that way. Then that will be the last year. Or you could just make sure that it's more than 0. Actually, doesn't make sense. Doesn't make sense, yeah, because it must be more than 150. If not, you don't have enough money to give out the last bursary. Okay, and so let's see. Here they gave more than or equals to 0. Actually, let me think a bit. Did I think of it wrongly? This is referring to, let me read the expression again. Amount in dollars remaining in the fund. Okay, sorry, I think I'm making it too complicated. Just think of it as positive. Just think of it as positive. Okay. Then from there we work out an answer and then we think logically. Okay, so if you make this more than equal to 0, you can take log, you can bring this term over, divide by negative of this, and then you take ln or any. I actually don't need. Just make this guy the subject. Do I need to go through this part?
Don't need.
Don't need. Okay, then you can use a GC. You get 25.44. Then here they rounded up to maximum 25. Now here I'm a bit irritated by the answer because they are not considering the fact that you need literally $150 to make sure you have enough money. You make sure you have you still have enough money. It's possible that even though it's 0.44, you round down up to 25, right? It's still not enough money. Like maybe it could be that it's 24. Maybe on the 25th year, there's slightly less than $150. Could be $149. Then you cannot give out the bursary. Okay. So, but never mind. We use this 25.44 and the 25 as an approximate for our answer. Then we just manually use the expression here to calculate how much money is inside. Is left inside the fund. So we just substitute in this guy. Sorry, substitute the n with 25. Can you key in for me what's the value here?
Uh, 65.6.
So basically only $65 left after giving out the 25th year, Right? The $65 left. So can we issue on the 26th year this time?
Cannot.
Cannot issue on 26th year. There will be an extra $65, but not enough to make a $150 bursary. So we cannot give out on the 26th year, so it's 25. Okay, can then. This makes sense. Just more than equals 0 is fine. But yeah, okay, I think this is I was thinking too complicated. Don't need, just more than equals 0 is fine. Okay, then the last year will be 2035. How do you calculate the last year? Because we started in 2011. So just plus 25. Okay?
Yeah.
Last year where you can issue. Okay, good. Do I need to care about whether you're giving out 2011, maybe it's 2034, 2036? Let's think a bit more precisely. Fund established beginning 2011, gave out end of each year. First year of giving out is 2011. N is referring to n of n years. If n is equal to 1, that will be the amount of money left after you give out on 2011. Is it? Or is it 2012? N equal to 1. Let's see what is that amount. If I substitute in n with 1, I obtain a value of 2437.5, which it means that I gave away how much? I have a net loss of 62.5. Right, that's because of the interest. Okay. Okay, I don't need to think so hard. It's just plus. It's just plus 25. And then we get 2035. Let me know if you don't agree with the answer.
Oh, okay.
Can?
Can.
2035? Okay, good. It's already 1 p.m. I'm not sure if I have time. I don't have enough time to go through. I have a next lesson. I need to be at. I need to leave by 1:15. Yeah. How many more questions? So many. Okay, wait. I just look at the ones you circled. Okay, this fellow. Wait. Maybe I'll start from the bottom. Start from the bottom. Oh, 16. Wow, one whole question. Hey, this one, matter of difference. Have you watched my video or not?
Huh? From where?
You haven't watched the video? I have a 4-hour free video provided for you. Go and watch. I went through the A-level questions. Please go and watch. Once you see that, you will understand how to solve this question. I'm not gonna go through this one. Question 16.
Oh, okay.
I think I included it in the playlist. You go and look up the sequence and series, part 1, part 2. Okay, this guy, using your answer, find this fellow. Okay, let's see. Okay, this one, you just need to. Okay, this one, you just need to realize that it's very closely related to part 2, right?
Yeah.
What's the difference?
It's +3, but then +2, but then I don't know.
Yeah, so all you need to do is to manipulate it so you can recover the +2, recover the expression +3. So +5 can be split as +3 +2, agree?
Yeah.
Then you can just multiply 2r + 3 with 2 power r and 2 multiplied by 2 power r. In other words, the following. Sorry, I go to 1 to n, I go to 1 to n equals sign. Can?
Yeah.
Then you can split out a summation, right? You can always split out into 2 separate sums. Is that clear?
Yeah.
Right, it's a summation, right? Maybe there's an extra pair of brackets here. Then you can just split it up into the 2 sums. But the first sum, you already got the answer, right? You can just use the answer, whatever it is. Hey, did you get the answer? This guy, I trust that it's correct. Then just sub in, no? N plus 1. Because it's literally the same. The limits, they didn't even play any tricks here. It's 1 to n, 1 to n. Nothing tricky here. So you can literally use the answer from part 2. N plus 1 times 2 power n plus 1 plus n times 2 power n plus 2. Okay? And then don't forget the plus 2 times 2 power r. But look carefully, what is this expression? Let's just rewrite it as 2 power r plus 1. What is this expression? They won't test outside the syllabus one. You only got 2 options. You only got 2 options.
This is a GP.
Yes, correct. It's a geometric progression. So in that case, what's the formula?
The A1 minus R to the power N1 minus R.
What's A, what's R, what's N?
Yes. 2.
A is what? No, answer one by one. What's A, what's R, what's N? A is it 2? Oh no. How do you get the first term? You substitute the R, the first index R with 1. So it's 2 power 1 plus 1. Does it make sense? This is literally the same as, wait, does that make sense?
Yeah.
Yes, okay, so the answer is 2 power 1 plus 1, which is 2 power 2, which is 4, not 2. Okay. Can.
Then the R is
Ratio is,
um
you just sub in a few values, or I equal to 1, I equal to 2 to convince yourself. What happens when the
2.
index increases by 1? Yes, it's just 2, exactly. What's the N? And it's just N, in this case, upper minus lower plus 1, right? And minus 1 plus 1. Okay? Yeah, okay. So now you got 4, you got 2, you got N. You got A, you got R, you got N. Just fill in the blank and you get your answer. Okay, I leave that to you.
Yeah, can.
Use formula. All right, so the trick here is to just make use of the answer from part 2 by rewriting the 5 as 3 plus 2. Okay? Can? Plus 3 plus 2. And then you distribute. Okay, next. Yes, 15 done. 14, 14. Okay, never circle, I don't look at it. Hence, find this fellow. Okay, so what you need to do is to realize that it's an index shift. Index shift. How do you go from, let's say R minus 3 to R plus 2? What happened? You increase by 5, right?
Yeah.
How do you go from, I'm just comparing left with left. I'm assuming they are not being tricky here. How about right with right? R minus 2 to R plus 1.
Plus 3.
Different pattern. Different pattern means got problem. Means they are trying to throw you. Left side, right side. No, you must compare left with right with left. Because they love trolling. For no good reason, let's just work it out the other way around. So this time, let's say purple with purple, green with green. So let's focus on the green with the green first. How do you go from minus 3 to plus 1?
Plus 4.
Plus 4, that's a common number. How about minus 2 to plus 2?
Plus 4.
Plus 4, what a coincidence. It's not a coincidence. It's purposely like that. I also don't know why they purposely try to make the expression in the other direction to confuse the students. No good reason, but I hope you understand the trick.
Yeah.
Trolling you. So there's a plus 4 index shift. So you can do the trick that I just taught you about index shift. So start off with the expression we had, R equals to 4 to capital N of 1 over R minus 3 times R minus 2. Then we can simply sub R with, let's say, R prime. In this case, make a clever guess. What do you think you want? How do you convert the R minus 3 into, let's say, R prime plus 1? I'll put a prime here.
Plus 4.
Plus 4. Yes, correct. Yes, very good, very good. R prime plus 4. Okay, so we're going to do that. Copy and paste the expression, but replace the R everywhere that had an R with R prime plus 4. R prime plus 4 everywhere. If I can just write it neatly and copy and paste. Okay, paste it here and then paste it there, as well as there. Okay, and then we are done. Can everywhere that had an R replace with R plus 4, R prime plus 4. Is it clear?
Yeah.
Clear. Very good. Simplify this expression. This will be exactly equal. Because I'm just simply substituting. Nothing wrong. Just substitute. You don't need to change anything. Just substitute. Sub. Right. Okay, I already mentioned it here. sorry, let me erase this. I already mentioned sub here. So now we focus on the new expression and see how we can simplify this. Oh, there's a +4 here. So how do you work it back up to a normal r prime? +4 bring over becomes -4. 4 minus 4? 0. Right? So if there's a +4 here, actually on top is invisible r prime +4. I'll just write in blue color equals to n. So therefore, the upper limit now becomes not just n, not n anymore, but rather
n minus 4.
-4, exactly. You see, +4 bring over -4. +4 bring over -4. Some students can do this inside their head. I cannot. Okay, I have to write it out. Okay, +4 minus 3, what do you get? You get r prime, right?
Yeah.
+4 minus 2, you get what?
The +2.
+2. You realize at this stage, it looks very similar to what we wanted already. R equal to 0 to n minus 6 over, and of the expression 1 over r. Sorry, I'm looking at the wrong expression. Am I looking at the wrong? No, I'm looking at the right expression. Wow, very stressed out already. Not enough time. Okay, then this one will become 1 over r plus 2 times r plus 1. Sorry, should be +1. Oh my goodness. Yes. Doing too fast already. Okay, is it right? +1? Is it better?
Yeah.
+4 minus 3 is +1. Okay, so you realize that it looks almost exactly the same as the expression we want, except for the fact that they requested for n minus 6. So this expression is actually exactly the same as the expression where you have n minus 6, provided that you add back in 2 more terms, right? This is summation of, maybe if I write it down, it's r prime equals to 0, 1, 2, until n minus 8, n minus 7, n minus 6, n minus 5, then n minus 4. These are the terms, right? I don't need so many. Just remove the n minus 8, n minus 7, good enough. I don't even need so many. But here we actually want up to n minus 6 only. So that means this part here, up to n minus 6. So is this expression at the bottom bigger or smaller than the expression on top? Orange versus brown. Who is the bigger guy?
The brown one.
Brown one is bigger. So bottom one is smaller, but you need this to be equal. Then you can only help the smaller guy out, right? So you have to plus what? What's missing?
The
R prime equals to what? This summation is from r prime equals to 0, 1, 2 all the way to n minus 6. What else is missing? What else is missing?
The n minus 5, n minus 4.
N minus 5 term and the n minus 4 term. So r prime equals n minus 5. That's one term plus r prime equals to n minus 4 term. So all you need to do now is to take the expression that's inside the summation, substitute in r prime with what?
The n minus 4.
With what and what?
N minus 4 and n minus 5.
Yes, correct. So you just need to copy and paste it everywhere that you see.
Do one by one.
Yes, correct. That's the last step. Must manually modify. The index shifting happens over here, and then the index shifting is these first 3 steps. You can do it in a few seconds if you're fast enough. And then finally, you just need to add back 2 more terms to compensate. Right? So replace the r prime with n minus 5. I'll just squeeze it in here, n minus 5, and then squeeze in the r prime there with n minus 4, n minus 4. And then you're done. Actually, one more step. This expression, you already found the answer, right? You already found the answer, yes?
Yeah.
1 minus n over 2. I trust your answer. 1 minus 1 over n minus 2 plus copy paste the rest. And you're done. Don't need to simplify. This one I also discussed in my 4-hour video. Please go and watch our 4-hour video. I got explained. It appeared before many times in A levels. It will appear again. Okay.
Can.
Yeah. Then part 3, what happened? Give a reason why the series converges and write down its value. So you already have an expression for this thing, is it? R equals to 4. It doesn't go to infinity. Hey, yo, what? No way it goes to infinity. How can you mark this correct? Wrong. If it goes to infinity, it's not converging. You need to write limit. Not necessarily. I mean, you can use the arrow notation. Let's just go to the question first. What question is this? Where's the number? What's the question number?
It's 13.
Okay, thank you.
But they say why it converges to, that means it already converges.
It does converge, yes. They're just asking you to explain why. So you show that it goes to infinity, definitely something wrong already.
Oh, I think my notation is not correct. Oh, so it's
Therefore-
n that is to infinity.
I
wrote the, oh yeah, I wrote wrongly. Yeah, it's okay.
Yeah, you need to replace the infinity with a capital N and let limit as n goes to infinity. Yes. Capital N, small n, depends. Okay, so here, did I get the answer wrong? I hope I didn't. Yeah, okay. Might have gotten the answer wrong. Not sure about this part. Okay, so this case, if you sum from I go to 4 to infinity, what you need to do is to replace the infinity with capital N, then take the limit as n goes to infinity. So this guy, you get an expression here. Using the answer from the previous part, what do we have? We had 1 minus 1 over n minus 2, right? From sum from 4 to n. Sum from 4 to n. Let me check your solution again. I think something was wrong with my expression. I just realized something. I know my mistake already here. Sorry. Okay, there's a mistake, which is that the summation here starts from 0, right? But the question, but this is not the same as your expression here, the 1 minus n 1 over n minus 2. Your expression there actually starts from 4. Does that make sense?
Yeah.
So that means I cannot directly replace. I still need to subtract away the first few terms. 1, 2, 3, and 4, and then 5. So only the 4 to n minus 6 term is 1 minus 1 over n minus 2. The first 0, 1, 2, and 3 terms must be subtracted as well. Okay, so I need to subtract away. Sorry, I need to compensate. Minus away r prime equal to 0. So this is just 1 times 2, right? I'm just directly substituting r prime with 0, and then subtract away the term where r prime is 1. So this guy, and then r prime is 2. Then r prime is 3. What else did I miss out? Yeah, these first 4 terms must be removed. And I have removed it by subtracting it. Okay? And then finally you get your answer. This entire expression. Can?
Okay.
Can? Okay, good. Next. This guy. You just have to replace it with the expression 1 minus 1 over n minus 2, and you take the limit. So what happens when you have 1 over n minus 2? What happens here is that if you draw the graph, here's how it looks. When n equal to 2, there's if you have an n axis and a y axis, what you realize is that there's an asymptote here. So you end up with a graph that looks something like the following. Like this. Like this. Okay. So what does it mean as, sorry, this is not x, it's n. What happens when n goes to infinity? What happens to your graph? It stays always slightly above the n axis, but it's going towards
0.
0. So this fella is going towards 0 as n goes to infinity. So it becomes 1 minus 0, which is 1. So you just need to show that it converges to a finite number 1. That's it. That's your reason.
Oh, okay.
Yeah, okay, that's all. All right, yeah, that's all. This is the limit as n goes to infinity. Okay, that's all the time I have for today already. I'll send you the file later.
Okay.
Okay, then for homework, what topic would you like? Graphical transformation, would that be okay? Or
yeah, I don't remember what we didn't go through.
yeah, graphical transformation.
Okay.
Okay, we'll go through that. Can?
Okay.
Okay, that's all. Thank you.
Okay,
Bye-bye.
thank you. Bye-bye.